All right, good morning. Thank you. This is super exciting. I'm super excited to be right next to the big #Devoxx sign. This is a fun time. My name is Arun Gupta. I work for Couchbase. Couchbase is a NoSQL database company. If you think of a key value or a document data store, think of Couchbase. That's how I see it. The talk about today is Docker. So how many of you are using Docker in your work life? About 20%. How many of you are using Docker in production? About half of those, so it's about 10%. All right, awesome. So this talk is a university talk. It's going to give you an introduction of Docker and Kubernetes. I'm not using Docker in production, but I do talk to a lot of people. I do help a lot of people bringing Docker in production. So my goal today is to share, hopefully get you started with Docker, and people who are using Docker in production, pick up a few tips and tricks from there. So one request I have is, well, just like everybody, I have a Twitter handle as well. So if you learn anything new about Docker today, use my handle and #Devoxx and say, hey, this is what I picked up on Docker. And same thing with Kubernetes. So #Docker, #Kubernetes, that'll be really useful. A little bit about myself. I'm an avid runner. I like to run. I've done a few marathons around the world. And something that I truly believe in is educating our next generation. So as part of that, I'm very actively involved with Devoxx for Kids. This was founded here in Belgium, and I took that organization to the US. I run the US chapter and the board, and I also run the San Francisco Bay Area chapter. So this is one of the books that I wrote with my son on Minecraft modding with Forge. So I think that's something in our generation to educate our next generation as well. So let's talk about Docker. So what is Docker? Well, Docker is, in that sense, an open source project and company. If you go to github.com/Docker, that's where it pretty much lives. And it's truly open source. I mean, the discussions, there are no private email aliases, there are no private discussions, the feature planning, all of that done truly, truly open source. And I've been following this Docker project for a while, so I know how it happens. Look at the number of watches, stars, forks, and it's extremely popular in that sense, heavily written in Go. What does it do? It really helps you create software containers. I'm not going to get into the benefits of containers, etc. There are lots of them, like snapshotting, security, sandboxing, etc. I won't get into those details. This is completely hands-on Docker in that sense. But it allows you to create a container for your software application. We'll talk a lot about that today. Java gave you the concept of Vora, which is write once, run anywhere. And the way that works is you write your program in the Java programming language, and then you have the JVM, which understands the bytecode. Once you take that program, convert it into bytecode or a class file or a war file or a jar file, that JVM understands that bytecode, and it runs it. And the JVM is ported to multiple platforms. That makes your Java code portable. Docker, in that sense, gives you PODA, which is package once, deploy anywhere. So it says, hey, I'm going to package my application using this. Now, containers have been used for a while, for many, many years in that sense. And a lot of people have been building containers in different ways. But what Docker gives you is a standard package format, which the Docker engine understands. It says, hey, you package your container using the Docker format, and here is a Docker engine, and that Docker engine then understands exactly how to run that package. So it really gives you that true portability. 3 key components of Docker: build, ship, and run. Now, the main concept of Docker is an image. So what you do is, typically when you want to build an application, your application has an operating system, it has a JDK, it has database drivers, a whole bunch of things, tuning, configuration, threads, etc. Now, typically you would write a chef or a Puppet script or something like that for that. Now, what Docker gives you is you prepare all of those instructions in a text file called as Docker file. And that Docker file, then you say, hey, by the way, take that Docker file and build an image. Image is sort of a build component of your Docker. Okay? And we'll take a look at it. How does Docker file look like? How do we build a Docker image and things like that? Now, once you've built an image, which is what I call as an application operating system, because it's basically what your application needs, not just the OS, but everything all the way up to the app stack. So you build that Docker image, and now that Docker image can be shared with others. How do you share the image? Well, sharing is the ship component of it. the default mechanism for sharing is Docker Hub or hub.docker.com, which is basically a SaaS. Anybody can create an account on Docker Hub, and they can push an image and pull an image. So it's purely REST-based kind of interaction. And as a matter of fact, when I show the workflow, you will see exactly it is REST interaction. So you built an image, now you want to share it, because sharing is a good thing. That's what our parents tell us. So you build an image, you share it. Well, somebody has shared an image, you pull the image. What do you do with the image now? You run the image. And the run component is the last key component of Docker, which is called as a container, which is a Docker container. So the way I want you to think is Docker build is image, Docker ship is registry or distribution component, and Docker run is the container component. So those are sort of the three pieces. We're going to be heavily focusing on the build and the run component today. There are interesting components on ship, but not so much as on the build and the run side of it. So we'll be heavily focusing on that side. One of the most common questions people ask is, how is Docker different from VM? And huge props to Docker documentation. Really good, really awesome, really developer-friendly. This is a snapshot from their documentation, as a matter of fact. This explains exactly how Docker is different from virtual machine. So on the left, what you see is a classic virtual machine environment. If I look at it, I have an infrastructure, hardware. Let's say my MacBook, for example. I want to virtualize something over here. On top of that, I have a host operating system, OS X. On OS X, if I want to do level 2 hypervisor, say VirtualBox, so that would be my level 2 hypervisor. On top of that hypervisor, I could run multiple operating systems. CentOS, Ubuntu, Fedora, Windows, all of those can run. Those are full-blown operating systems which require interaction with the underlying OS X to a minimal level. Okay, so that's very bare minimal in that sense. And then if you want to bundle an application, you bundle an application as part of your operating system. So that's how the virtual machine world works. In the Docker world, same Mac, same operating system, host operating system. On the host operating system, what you have is a layer called as Docker engine. And on that Docker engine, what you do is you run a minimal operating system. Or rather, what you run is a Docker image, which actually has your minimal operating system and your application and everything else packaged in there. The key concept here is that minimal operating system then talks to Docker engine. The Docker engine leverages, or is really reliant upon some of the key features of Linux. Things like C groups, things like namespaces. It really relies upon those to implement the functionality, the sandboxing, the security, the snapshotting. It relies upon those features, and the Docker engine really implements those features. And you can see by the difference of the size, if you look on the left side, it's a much bigger, it's a full-blown operating system. If you have to install, say, Windows, it's a few gigabytes. If you have to install Ubuntu or Fedora, those are, again, in a few hundred megabyte ranges, as opposed to a minimal operating system on the Docker side, which is on a lot lower side of it, okay? So we will, again, compare and contrast these differences as we get into the code. By all means, one thing I want to mention is every few minutes, every 15, 20 minutes, I will switch to Twitter, and I will look at my handle and Devoxx hashtag. If you have any questions, feel free to post over there. I think that'll be the most interactive way, and in between, I'm happy to keep it interactive as well. Let's look at the build component. How does build component work? Well, image is defined in a text file called as Docker file, and I'm starting with capital D. Now, that's the recommendation, that's the convention. It doesn't have to be Docker file, but that's what I've seen pretty much everybody using consistently. And in the Docker file, effectively, you have a list of commands to build the image. What does the list of commands really look like? Well, the first one, I start with the hello world. How do we start with the hello world? Well, here I'm saying from, capital in from is a Docker file directive or instruction. You say, here is my base operating system that I'm going to use for my image. So I'm starting with Fedora :latest. Now, Fedora is the base operating system, and effectively is being pulled from Docker Hub. :latest is an optional tag. If you don't do that, that is the default. Now, Fedora has multiple versions. If you want to specify your version, that's where you will specify your version. Okay? And then, in that image, all you want to do is print hello world. So you're saying command or cmd echo hello world. Very simple. So when we're going to build this image, we will see and how the image is created for us and how we run the image. So, and we will talk into the concept of a union file system, which basically says how each command is effectively a layer. And it'll be more clear when we talk about it. Let's take a little bit more complex example. Don't be intimidated by the second line in this image, but the first line says, I'm going to take from jboss/wildfly image. This is the official wildfly image. Wildfly is a Red Hat's open source application server, and the commercial version for that is JBoss. So I'm going to build this image from JBoss Wildfly. By default, if I write only that as part of my Docker file, is going to not only download the image, but there is a command in that image. That means it's going to, and that command basically fires up Wildfly. So if I just say from JBoss Wildfly, it automatically fires up the Wildfly container for me. So that's pretty cool. Now, in that container, what do I want to do? In that container, I want to deploy my war file. So here, what I have is, in that sense, if you look at it, the second command says curl. And now all I'm doing is curling from a website where a war file is living. And in the second part of the curl command where I say -o, I'm saying, oh, take this war file and drop it into this directory. Because I know when my Docker container is running or my Wildfly container is running, in that container, here is this standard directory /opt jboss wildfly standalone deployments that is being watched for deployments. So if I drop my war file over there, it's automatically going to get deployed. So 2 lines, but all I've done is I've taken my war file and I've deployed it into the Wildfly container. Very simple, very easy way to get started with. If you go to the URL at the bottom of the screen here, it'll give you a complete Docker file reference. So we just saw a couple of simple commands here, but effectively, from is the biggest command. From has to be the first command where you say, okay, this is my base operating system or base image that I'm gonna derive from. I can say run, that I wanna run a command, like we did curl, things like that. I can say command, where I want to run a command, like echo and things like that. You can start exposing ports that, okay, hey, my Wildfly is running. It's running on port 8080. I'm going to expose that port publicly. You can start setting up environment variables. You can add, when you build a Docker image, you have to provide a context. And the context has to be either a current directory or a URL. And then from that context, everything else operates. So for example, if you say add, it's going to look at that context and it's going to take a directory and add it to the containers file system. There are entry points which says, okay, what is going to be my entry point to the container? By default is shell. You can change that to echo or some other command. There are lots of methods over here. So let's see how the Docker workflow really looks like. Now, I have a client. So there are three key components effectively. On the left, what you see is a Docker client. And once again, props to Docker documentation. This is again from Docker docs, or rather docs.docker.com. So on the left, what I have is my Docker client. On the middle, I have Docker host, which is my Docker engine, which is where my Docker daemon is running, which understands the commands. And on the far right is my Docker hub, or the registry. Now, in the registry is where all the images sit. That's a public registry, hub.docker.com. It doesn't have to be public. There are private registries by JFrog, where you can easily set up a private registry inside your firewall. There are private registries by Docker itself, or Docker registry. If you Google for that, it'll give you that name. So there are private registries that can be set up. By default, people start with the public registry. It's a lot easier to get started with. So the flow in that sense is, I have a Docker client on my machine. Then I need somewhere a Docker host. Could be on my machine, or could be somewhere in my firewall or anywhere where Docker host is running. Very easy to get started with. I'll explain that. And then a registry running in the public domain. So now from the client, I issue a command. Docker is a CLI, in that sense. You say, hey, Docker, I want to run an image. Okay, so you want to run an image, you give a command to Docker host. How do you guide it to Docker host? Well, wherever Docker host is running, Docker is heavily environment variables driven. So what that means is, you set up your environment variables. What is my Docker _ host? What is my Docker, where are my certificates living, etc. There are 3 or 4 variables you need to set. But once you have set up those variables, then the client knows, I'm going to look at those variables, I can talk to that Docker host. So effectively, you can have your client configured to talk to any Docker host at a given point of time. And you can have multiple Docker hosts for that sake. So client gives the command, I want to run an image. And it's going to give that command, and it goes to Docker host. Docker host says, hey, do I have that image? If I don't have that image, it goes and pulls that images from the Docker registry or Docker hub and brings it down to Docker host. And then it runs it. All the images are stored on Docker host. There is nothing on the Docker client. Docker client is merely a dummy terminal, so to say, which talks to Docker host and gives the commands to Docker host. All the communication between client and host is REST, and similarly between host and registry is REST. It uses the REST protocol in that sense. So when you say, I want to build an image, it builds an image, and whatever is required to be downloaded as part of that building, the downloading is done on the host. When you pull an image, pulling is done there. When you run an image, running is done there. So everything is done on the host. And then, of course, it talks to the hub if it needs to. So here it says, how the Docker client gives a command to Docker host. It downloads the images. There are a couple of images on the right side in the Docker host it's showing. And on the left side of the Docker host is showing how the containers are running. So how does the image look like, really? Now, in terms of an image, Docker uses this concept of a union file system. Now, there is a boot FS or kernel, which is a very, very base layer of Docker for that sake. In that sense, that's what really gives you all the functionality of C groups, namespaces, kernels, if it needs to talk to. I mean, there's a scratch image as well. You don't want to even start with the operating system, build your operating system, you can do that. But most of the time, people start with a convenient operating system. So on that boot FS kernel, you write first layer. What that means is, in a layer, you don't write anything. If you want to write something, you put another layer on top of that. So in this case, for example, I'm building a base image. I'm using the base image of CentOS. All I'm saying is CentOS:7. So I'm going to use the base image of CentOS:7. On my boot FS, I'm going to put first layer. Okay, that's cool. Now, I'm building, one of the thought process in Docker is how everything has to be done in a very generic way where things are more generically applicable. So somebody has built a CentOS image. Now, should CentOS image only be used for JBoss? No, CentOS is a very generic image, so it should be used by anybody. So in this case, what we are building is a JBoss wildfly image, and I'm showing you how that architecture looks like. We happen to be using CentOS:7, and that's okay. So at the bottom, I have a CentOS:7, but that means the 7th version of CentOS operating system image. On top of that, Red Hat built a JBoss base image. So because it requires certain apt-gets, so it did the apt-gets, and it built a JBoss base image. So that is the base image that anybody within Red Hat is trying to build a Docker image will use that as a base image, because it has done all the apt-gets. The big concept here is dry. You build a base image, use that again and again, as opposed to everybody building their own thing. Now, JBoss, in that sense, in the JBoss base image, doesn't have to be JDK only, because JBoss is a polyglot application server or polyglot middleware in that sense. So there's a base image on top of which you added the JDK layer, okay, JDK 8. And again, we're saying :8. What that means is saying there is a 7 version, there's an 8 version, but it downloaded the image here, and I have a JBoss base JDK 8 image. And finally, on top of that, I have installed Wildfly. And installation really means is I'm going to run some commands. I'm going to say, hey, download Wildfly, unzip Wildfly, and it's as simple as this in terms of install. End of the day, and we'll see when we will pull certain images, you will see how these individual images are pulled from Docker Hub, and they're layered on top of each other. And there are rules how the unionized is done, but they are effectively compressed into one Docker image for you. And there are rules like if there is something on the top and on the bottom, which one takes precedence. But following those rules, those are all compressed into one image for you, and that's what you get effectively. Now, we talked a little bit about that Docker requires those Linux functionality, things like C groups, namespaces. But those don't exist on Windows. Those don't exist on Mac. So how does it work? Well, meet Docker Machine. Docker Machine is basically allows you to get started with Docker very easily on a Mac or a Windows. Remember, it's only for Mac and Windows, even though you can use it on Linux, but that's not the target. On Linux, it's natively supported. On Linux, you can say apt-get docker engine or yum install docker engine, and that should be all right. You should not have to do that. So the way Docker machine, again, Docker is a CLI, Docker machine is a CLI. You download Docker machine, you install it, but once you have done the installation, you're going to say, Docker machine, I want to create a Docker machine. Docker machine works on the concept of virtualization providers. And I'll show you the list of virtualization provider, but effectively, you can say, hey, I'm running on a local laptop, and I just want to use VirtualBox for creating my virtual machine. Or I want to run on Amazon, I want to run on Azure, I want to run on DigitalOcean, I want to run on different virtual providers, and that you can specify as what your driver is going to be. And then finally, you give it the name. So you say Docker machine create, driver, machine name. There are a bunch of different options. We're not going to go into that, but that's sort of your basic idea. And that's how I run Docker on my Mac. I pretty much create machines on a daily basis. I delete machines, I add machines. I can have multiple machines on my Mac here, and that's normal. Once you have created a Docker machine, remember I said Docker CLI talks to Docker machine using environment variables. It shows you a list of environment variables that you need to set in order for have the Docker CLI to Docker host. Now, typically it's a distributed environment where you might have a Docker host running on a separate machine, but for development, I use all the time Docker machine on my box, and Docker CLI is also on my box. But even though they are on the same box, does not mean they have some internal protocol. They still talk to each other using REST, as if, yeah, they're just two different entities. But then your Docker client can say, create images, pull images. It can start, stop, restart containers. All of that concept is available. And Docker is on a very good release cadence. On every 4 to 6 months, they do a new upgrade to Docker. Docker 1.9, as a matter of fact, was released last week. So once you have built a Docker machine, it uses boot to Docker. We'll talk about that in a second. But it uses boot to Docker to spin up your virtual machine. If you were using 1.6 or 1.7 or 1.8 and new version of boot to Docker or Docker machine has been released, how do you upgrade? So there's an upgrade command where it'll automatically download the new virtual machine image and upgrade and all those things for you. The important part to understand is not recommended for production yet. And this is from Docker's website. So that's an important, very important aspect to understand. I don't know anybody. I know a few people who are in Docker production, but I don't know anybody who is using Docker machine in production. I mean, it's listed on their website, so that's kind of easy. So how does it work? Well, there is, as I said, one of the things, I like the fact that earlier Docker machine was a single CLI, but it was a big CLI. But now they have refactored the code where it's a zip file. So you download the zip file, and once you download the zip file, you unzip it, and then there's an install process. And the way the whole thing works is machine core has been moved into one binary, and all these virtualization drivers like DigitalOcean, Azure, Rackspace, EC2, Google Compute Engine, all of those are separate binaries. So think of that as a very classic monolithic to microservices refactoring. Docker machine was a big monolith. They refactored it into microservices. These are all separate binaries. Now each of those binaries can evolve independently. What's still missing is the API where people can write their own machine providers. That's coming in the future release. So what that would allow you to do is, let's say you have a custom virtualization platform, you can write your own machine provider very easily. So that's sort of the cool thing about it. Now boot to Docker is sort of a predecessor of Docker. I wouldn't say predecessor to Docker, but that was sort of the first thing that I started playing with about year and a half ago when I wanted to play with Docker. But effectively, boot to Docker is just an implementation detail of Docker machine now. And what that means is when you say Docker machine, behind the scene, it downloads boot to Docker ISO, it caches it locally, and it uses that to create a virtual machine. So effectively, Docker machine is a virtual machine in which your containers are running. That's not a necessary case if you're doing it on a Linux box, though. But the recommendation from Docker is, if you are using boot to Docker, then you should definitely migrate your machine, boot to Docker machine, to Docker machine. And there are commands for that. This particularly VirtualBox import boot to Docker VM switch allows you to migrate your existing boot to Docker VM to Docker machines, and that's kind of pretty clean. On Docker website, they actually give a comparison between boot to Docker and Docker machine, so that's useful to know, but I have not interacted with a lot of people who are still using boot to Docker. There is awareness that is required, that don't use boot to Docker and use Docker machine, and that's okay. So that awareness is what we are working on. Now, the easiest way, all this description, like my head is spinning, Docker machine, Docker CLI, Docker I mean, there's so many Dockers. How do I get started? Well, Docker Toolbox. If you have never started with Docker, Docker Toolbox is a tool that they've created recently. It was done, I think, introduced in Docker 1.8. Easiest way to get started. This is, again, primarily meant for Mac and Windows. There's a lot more native support in Linux itself. But effectively, it has Docker CLI, here's the Docker client. It has Docker machine, which is 0.5.0 right now. Docker Compose, which used to be sort of a stepchild on Windows box. We used to work terribly on a Windows box, but that is, I've heard, is a lot better supported as part of 1.9. So Docker Compose used to be Mac only, but now is Mac and Windows. And we'll talk about Docker Compose in a second. Well, not second, but a little bit later. Docker Kitematic is a tool, people who like GUIs. Hey, I want to install my Docker machines from a GUI. I'm not a command line person. So it's basically meant for people like that. It has the boot to Docker ISO included in it. And because you're using VirtualBox as a development provider or the virtualization provider for your development machine, it has VirtualBox included into it. One click, you download, install, and everything is ready to go. So very clean, very simple, okay? Let's look at some code now. So I'm going to switch to Twitter for a second and see if there are any questions. Oh, whoa, 31 new notifications. Let's see if there are any questions. One more for What is the best way to detect changed versions when using curl within the Docker file? Yeah, that's more like a timestamp kind of a thing, So you have to look for it, when your war file is ready. When I get to the Docker Compose part of it, I'll talk briefly about how to go from dev to prod and things like that. So I'll cover that question. That's a good point. Want to play with Docker on Windows? Oh, somebody's pitching their session. That's all right. Ready for this? Anything else? Anything else? Anything else? Okay. All right, cool. Oh, 3 more. Docker Toolbox looks cool. Go, yes, we talked about Go. What's the preferred way to allow containers to communicate with each other? Networking, yes, we'll talk about networking. I have a lot of content on networking. Container linking is passé. Don't talk about it anymore. All right, clean machine here. So let's take a look at, well, let's see how the font is. A little bit bigger, maybe. All right, cool. So here I am. I'm going to say Docker machine ls, okay? Now, I did Docker machine ls, and here is showing me, hey, you got 4 Docker machines created here, of which these are not active. This guy is active. I just created this as a backup machine in case things go wrong with internet, which they do all the time. It says, what is the driver you're using? It says the state. So these 2 are stopped. These are running. And this is the URL. This is the IP address of the machine. It uses TCP protocol at this port for all the REST interaction. And that's what it's showing. And on the right side is showing swarm. I don't want to jump the gun, but we'll get to that when we get to that, okay? So how do we get started? Well, let's do this. So we say Docker machine. I'm going to say create. Well, first of all, ever in doubt, do Docker machine -- help. -- help is universal that works across tools. Really cool, really easy, okay? I found this very effective, and I use it very heavily all the time. And whenever in doubt, try this. So I'm going to move this guy a little bit up. You can see it clearly, yeah? That's cool. So I'm going to say Docker machine, and I'm going to create. And I'm going to say, I want VirtualBox, and I want to create a machine called as Devoxx. So now, because I've created Docker machines already, all it's going to do is it's going to look at my, well, let me open up a new shell here, and I'm going to take you to Docker here. This is a .docker directory. In here, you can see machine, and in here, you can see cache, and in here, you can see there's a boot to docker.iso as well. This is an attempt from a previous upgrade that I was doing That didn't go well, but you can see it's a tiny Linux VM. It's about 31 megabytes, so not bad. 31 megabyte in which you can run all your Docker containers. It's pretty cool. So go here, now go to machines. There's a folder for each machine here. Now, if I go to say Devoxx backup, one of the things that's important is to understand is, once I create my machine, there is a copy of boot to Docker ISO that is already cached in the directory. So you know exactly that, hey, I created this with boot to Docker, or I created this with Docker 1.9, so that in case you are creating subsequent machines with later versions, it's not going to hit you. You still can talk with the same version of Docker, so it always caches that version. But once you upgrade it, then it downloads a new VM, does the timestamp check, etc., and then put the new boot to Docker ISO as part of your machine description itself. Okay, so that's that. Now, if I look back here, okay, that's cool. Let's move this up so that I can see it clearly. Here we go. So now, this is a simple process by which you create a Docker machine. Lots of output here. The important one to look here is Docker machine env devoxx. Okay, so I'm going to copy this, and I'm going to run it. When I run it, it shows me, hey, there are these 1, 2, 3, 4 environment variables. So Docker TLS verify, host, cert path, Docker machine name. Those are the variables I need to configure in case I want to talk to Docker. So how do I do that? I say eval, and well, again, I'm a lazy guy, so I'm going to just copy this here. I copy it, and I paste it. And boom. So effectively, those 4 environment variables are now set in my environment. Okay. And now if I do env grep Docker, those are exactly set here. So now if I say Docker images, there are no images, of course, because we didn't create any image so far. So my Docker CLI effectively looks at those variables and talks to that particular Docker host. Now if I say Docker PS, which is the way I check containers, there are no containers running because we haven't started any. So that's kind of easy, okay? Now, let's build our very simple Docker image. I'm going to go to the one that I have already built here. So let's look at Docker file here. So very, very, very simple Docker file here. So it says from Ubuntu. By default, it just creates a shell. And in this case, I'm saying, hey, by the way, the command that I want to run is ben echo hello world. Okay? How do I build this image? So I say docker build is my command. Well, once again, if I say docker -- help, the complete list of commands automatically shows up here. The certificate, options, etc., all of that comes up over here. So now I'm going to say docker build, and I'm going to say help, and it shows me the list for that. So -- help is pretty much universal. I've never had issues with -- help. That's one thing I'm happy about. So Docker, I'm going to build. When you build an image, you need to give it a name. So you say basically tag in the Docker language. So I'm going to say hello world Devoxx. Okay? And remember, we talked about when you build an image, you need to give it a context. So I'm saying dot. That is my context. By default, the name is Dockerfile. Hit enter. So when I hit enter, now the Docker client is talking to Docker host, which is Docker machine running on my local machine here, and it's saying, hey, you don't have anything in there, so that means I need to download that image. And if we look at Ubuntu, Ubuntu is again a layer of images, so it's downloading each image, it's going to extract that image, and it's going to run that command. Command is just like another layer on top of it, but effectively run pretty cool. So step 1 was from Ubuntu, it downloaded all those images. Step 2, it want to run the command. So my image is here. Now, let's look at images. Ubuntu image is downloaded, and hello world Devoxx image is created for me. Nice and easy, okay? And you can see the difference here is 187.9 megabytes. That's my full Ubuntu image. Now, I'm using Ubuntu. What if I want to change that from Ubuntu to something like BusyBox, which is an embedded Linux? I don't want that fat of an image. I'm going to change it. And now I'm going to say build, and I'm going to say hello world Devoxx 2. Let's build it. Let's see how does BusyBox operates. Boom, it's done. Aha. Let's look at Docker images then. So now, BusyBox, if you see, is 1 megabyte. Yeah, that's pretty cool. So your entire image is 1 MB. A lot of people I talk to, they go production with BusyBox, and that's okay. So let's see. Okay, so we built a simple image. In that image, basically, you can start adding a lot of commands that you want to do. Now I want to run that image. Okay, so I'm going to say Docker. I'm going to say run. I'm going to say help. Aha, lots of switches. I can look at that. I can see what they are. But what I want to do is I want to say run. I have to give it an image name. So I'm going to say, let's see, Docker images. So I'm going to say run, and I am going to run my first image here. That's it, because it's just doing bin hello world. So that's very clean, very simple. Now I can do that with hello world too, and they're going to do the same thing. Well, it's hello world, so it doesn't really matter. Let me show you another fun thing. So all I want to do is I want to run the Ubuntu image here. Okay. By default, it runs as in a daemon. I mean, if you're running JBoss Wildfly, for example, it'll stay there, and you can't interact with it. You can't assign. It doesn't assign a TTY. So what I'm going to do is I want to assign a TTY now. I'm going to say interactive, which is -I, and T means assign a TTY. So that's cool. And instead, I want to run a shell. So let's say simple shell. Here you go. So now I'm logged into the container. I'm into the container. I have a shell open into the container. Okay. So if I look at it, I'm in the root here. Just for fun, all I'm going to do is rm-rf star in the root. Let's do that. Okay. So now if I do ls, oh, it cannot find because we deleted all the commands. Well, let's get out of it, and let's run it again. If I do ls, now it works. Docker containers are like diapers. If you shit in them, you throw them, you put on a new one. That's what we just did. So the point is, and if you talk to people, who are running Docker in production, that's what they do. They don't keep repurposing the Docker. That no, I'm going to keep repurposing that Docker container. If that container is giving a problem, throw it. Just spin up a new container, man. It's cheap. To give you an analogy, on my Mac here, which is pretty beefy, mapped out 4 core, 16 gig RAM, it's pretty decent. I can run 3, 4 virtual machines comfortably, the big ones, very easily. I've been able to run up to 10 to 15 virtual Docker machines here very comfortably. On each machine, I'm able to run up to 50 containers very easily. Just to give you a scale in terms of virtualization and Docker containers. So it's cheap, it runs really fast. So let's get out of it. And now I'm going to say Docker PS. No containers are running, but I can say, hey, by the way, Docker PS-A, and it says, okay, so this is, I hate this part of Docker. It's like such a big status. I have to really have a 128-character window. It's really going back to mainframes. But here it says container ID. It gives each container a unique ID. It says what image was being used, what command was being used, and it's saying hello var, but I can say --node trunk, and it shows me the full command. It says when it was created and the current status. So it's being exited. So that's all right. Okay. Now we talked about JBoss Wildfly. So what I'm going to do is I'm going to say Docker run. I'm going to run it in an interactive mode. I want to run JBoss Wildfly container. So I'm going to say JBoss/Wildfly. But when I'm running this container, at that point, I need to do port forwarding because JBoss Wildfly exposes port 8080, and I need some mechanism by which I can test that, okay, that container is actually up. So a couple of options. I can do -p, where it will look at all the ports that are exposed and map them to a random port. Or I can do -p here like this, and I can say, take a port on my host and map it to that port in the container. Let's run it this way. Now, once again, JBoss Wildfly is not here, so it's going to download all the images. Remember we talked about base, JDK8, everything. You can see live how those images are downloaded. And once it's going to so it's a two-step process. It downloads the images, then it extracts the image, and then it runs the container for you. So once all of that download is done, then it's going to fire up your container. So you can see most of the download is complete. So it does the pull, it downloads, it extracts, and then it's going to fire up the container. Well, while it's doing that, let's switch back to Twitter and see there are more notifications. Compose is the only tool for combining separate containers for full application. At this point, yes, and when I get to the compose part, then I'll talk about it a little bit more. Is creating a Docker machine live at Devoxx? Yeah, that's a huge window. Did I hear correctly? Linking containers is passe. Linking, well, let's address that question when we get to Docker networking. But almost, yeah. I mean, there are the issues with, well, I don't want to jump the gun. Let's get to that later. Excuse me. One of the things I want to say, Docker doesn't require you to know Linux skills. Excuse me. Docker does not require you to know Linux skills in that sense. I mean, it's a CLI, but you don't really need to know Linux in that sense. Oh man, yeah, I want to be productive. I want to use Linux, Mac, not Linux, seriously. But that's my thing. We're not getting into a religious war here, don't worry. So here, okay, so now I have started my Docker container, which is my Wildfly container. So how do I test it? Hey, this is running in an interactive mode. If I stop it, it's going to go away. So what I do is I go to a different shell, open a new shell here, and here I'm going to say, let's see the Docker machines, okay? Oh, sorry. So if I see Docker machine here, it says they're all running, when the 3 are running, but none of them is active. So how do I make it active again? So I say Docker machine, env, and we did Devoxx. And now if I say Docker machine ls, and there you go. So I got Devoxx here with star active. That's pretty cool. Okay. So now if I say Docker ps, it shows, my container is running. Started about a minute ago. These are the ports that are exposed. And I like this part. If you don't give it a name, it gives you a combination of 2 strings and gives you a funny name. In this case, it's silly Hypatia, whatever that means. But now I can say Docker machine, IP, and the name here is lab. Oh, not the lab, sorry, wrong one. Devoxx. So my IP address is here. So all I'm going to do is I'm going to say curl. I'm going to say Docker machine, IP, Devoxx. That's what I want to do. And I'm going to say here HTTP. And I know my port is forwarded already. If I do this, it just brings a default page for me. So once again, the command is HTTP IP address :8080, and that's it. Now, in this container it's running, I can drop my war file, and it'll automatically get deployed. Okay, that's cool. Okay, let's look at the notifications again and see what we need to do about it. Correct. This is the last layer. So BusyBox, yes. So I mean, you have to. BusyBox is again tiny Linux or embedded Linux. So you have to do a lot more on top of it. All right, multi-container application. Now, typically, Docker containers do one thing, and they do one thing really damn good. But what that means is, if you want to build an application, your application will have an application container, a database container, and a bunch of other things, messaging and all that stuff. So you will have multiple containers running. So that means if I'm running my SQL container here, MySQL, yeah, I should be talking about Couchbase, sorry. But here is saying I'm running a MySQL container. This is how I would run it, and I'll give it a name. There's certain environment variables I'm setting over here. And I'm saying -d that because I want to run it in a detached mode. I don't care about it. Running it as a daemon. If I want to run a Wildfly here, so now I can have the 2 containers talk to each other, first of all. One of the things here that we talked briefly about is container linking. I have given my MySQL container MySQL DB name. I've given my Wildfly container a name. But the way Wildfly and MySQL talk to each other is using JDBC. And so the Wildfly needs to know what the IP address and the host IP and port and the database name are on the MySQL side. So if you do container linking, Docker has this weird naming convention by which it says if you link the containers, it's going to expose the host port. Lost for a second. So it's going to expose the host port and IP address, etc., to the container that you are linking to. So in this custom image, which is at the bottom, Arun Gupta /Wildfly MySQL Java E7, we are actually using the environment variables and creating the JDBC URL accordingly. But there are limitations with that, and we'll talk about that when we get to networking. So if I want to run those commands, if I want to run a multi-container application, which is very, very normal and which is what people do, how do I do it? Do I run those multiple commands, put them in a bash file? Do I use Chef, Puppet, Ansible, Salt, or some new flavor? That's where Docker Compose helps. Docker Compose helps you define and run multi-container applications. Basically, you define, configuration is defined in one or more files. Docker compose.yaml is the default file name. You are not restricted to that name, but that's the default one. So if you say Docker compose up, is going to up your application, looking at that Docker compose YAML file. You can have two files in a folder, so docker compose.yaml or docker compose.override.yaml. You can have those two files in the folder, and Docker compose override will, by default, your definition on the Docker compose file. And we'll talk about what the override and extends really mean. You can specify multiple files using -f, and that's okay. All the paths are relative to your base configuration files. Whichever file you specify using first -f, that's going to be your base configuration file, and everything builds from that. It's very great for dev, staging, and CI. It really allows you to reduce the impedance mismatch between different environments. And I'll talk about how do people go to production, for example, with Compose, although it's not heavily used. Here's my sample docker compose.yaml. We showed two different commands, and here in one YAML file, I've put my two services. So you can see MySQL DB is one service, and my Wildfly is another service. So that's the terminology that Docker Compose uses. Now, each service requires an image name, that what image you want, what environment variables you need to create. And this is not right, because environment variables is a bunch of arrays. I should have dashes over there. Then my Wildfly, again, I'm saying what custom image, and then I'm creating the links. One file, if I fire it up, is just going to do the whole thing for me. And again, you can see the linking, how it's done. It was done in the commands using --link. Here is just done implicitly by using it. It figures out which containers need to be started. One of the problems, or the biggest problem rather, with linking is confined to a single host. You can't do multi-host linking with that. So that means your Wildfly and MySQL have to run on a single host. That's a single point of failure. That's a fundamental flaw right there itself. That has improved significantly, and we will talk about the networking part of it. Now, we talked about JDBC connection. Here you see a pretty daunting command, but that daunting command basically is a standard Wildfly command, which you use using JBoss CLI to create a database, a JDBC resource. You can say data source add, blah, 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 a whole bunch of things in there. The key values you're looking for are the environment variables. That's the ugly Docker environment variable naming scheme. I don't like it. And why I don't like it? It says DB, which is okay. Then it says port 3306. Like, who puts a port number in the environment variable itself? Really? And you're giving me an IP address, not the port number. Why do you put that? Who designed that? Seriously. And then the second one is port 3306 TCP port. If I know the value, why are you putting that value in the environment variable name? I've never been able to understand that. Anyway, effectively, in my Wildfly configuration file, it gives me an IP address. Now, this 172.17.02 is an internal IP address that is assigned to Docker, and 3306 is a port where MySQL is running by default. But effectively, by container linking, I got the functionality by which I can link the two containers very easily and have them run. Another example I want to show here for Docker Compose is I wanted to run a Couchbase cluster. I want to run a Couchbase cluster. It scales very well horizontally. So how do I run a Couchbase cluster now? So once again, I created a Docker Compose file, a very easy way to get started with. So you can see Couchbase 1, 2, 3. The key concept over here I want to talk about is how you can do volume mapping. That's a new concept in Docker. And volume mapping means, by default, if I'm running a database container, everything is confined to that container. And remember, we talked about containers being diaper. If they go away, hey, my data goes away. The process was rogue, but not my data. How do I get access to my data? That's where your volume mapping helps you out. So here, what you're doing is you are mapping in this case, in my home directory, I have a Couchbase directory where I have a node 1 directory. Since it's a 3-node cluster, I have a node 1, node 2, node 3, and I'm mapping those directories on my host, which is my Mac, to the ones in the Docker container. So /opt/couchbase/var is where all the data is written, and instead I'm mapping it over here. So it's no longer going to be written in the container, it's going to be on my host. So even if the container goes away, I can fire up a new container and still do the same mapping, and it's still going to be, my data is still going to be there. There are a lot more advanced concepts in volume mapping, which I'll get into a little bit later. But effectively, very easy way to give me a 3-node Couchbase cluster using Docker Compose. Talk about multi-host networking. We talked about the problem with links. Links was a good way to get started with, but effectively what multi-host networking gives you is, no animation here, oh man, life is tough. It allows you to create virtual containers, virtual networks, virtual networks, and you can attach containers to it. Effectively, it's basically creating a virtual LAN for you. It's a software-defined networking. And there are 2 kinds of networks that can be created. There is a bridge network that spans a single host. There's by default, if you fire up Docker, it runs, it creates a bridge network automatically for you. And that bridge network is the default Docker network, but now you can create multiple bridge networks. So you can start sandboxing your containers within a network. Or you can create an overlay network that spans multiple hosts. That's something new that they've introduced. I have a lot more diagrams and slides that will explain that, but start with that. But what that gives you the ability is, you can run multi-host, multi-container applications very easily. It works very well with Swarm and Compose, although the support in Compose is still very experimental. Think of it as a hacky approach. One of the advantages of this multi-host networking is there are pluggable providers. Now, Docker certainly has a default provider. You can say, hey, I'm using Calico, Cisco, Weave, Flannel, whatever your favorite networking stack is. You can pick that stack and use that to, as a provider. So if you're creating an overlay network, you can say, hey, I want to use Weave as my network. Use that as a provider and create the network across these multiple Docker hosts. So talk about a little bit about networking versus links. Well, the container in links, the containers are confined to a host. In networking, there are multi-container hosts. They can be deployed in multiple containers. Another problem with link was because it's reliant upon the environment variables, and what that means is, if my Wildfly is trying to connect to that MySQL and the MySQL is not up, that means that environment variable will not be visible to me or not be available to me. So my Wildfly will go bonkers and the application will not run. With networking, that's no longer the issue. We'll talk about that a little bit later. So that gives you the flexibility that the containers can really start in any order. So with links, we saw how my file looks like. I have my SQL DB service, and it was done using linking. So we know that. How does that change with multi-host networking? This is, by the way, a brand new feature introduced in Docker 1.9 last week. So with networking, my file changes like this. I still have 2 services. I add 1 new component over there in my Docker Compose file. So you can see Docker Compose I use pretty heavily as opposed to running the command online. But in the MySQL container, I say container name :db. Within it has to be code somehow. I don't know why, but you give a container name, and then in the environment of my Wildfly, I can just say db:3306. I know the port where it's running, and I don't need the environment variable, because you're consistently running your database across that port. So you just stick that port, you put that into the environment variable. How does that change? Now, once again, I go back here in my data source add command. What I'm getting here is MySQL URI. If I go back here for a second, remember my environment variable name here is MySQL URI. I use that environment variable. And in my Wildfly, what I'm getting is MySQL URI. And in my corresponding JDBC connection in the Wildfly configuration file, I'm actually getting db:3306. That DB is resolved completely at runtime using the networking stack, the multi-host networking option. And we'll talk about a little bit more about multi-host networking when we get a little bit later in the talk. Okay, cool. I got that multi-host networking, a little bit of concept of that. there's a concept in Docker Compose where you can override services. How does that work? So here, for example, a simple sample. I have a Docker Compose with one service using Wildfly exposing port 8080. I can have docker compose.override.yaml in the same directory, and now when I'm going to run the service, the port is going to be exposed at 9080 as opposed to 8080. And I'll show you how this file can be used more effectively. And effectively, the way I fire up my application, I say docker compose up-d. Simple, very simple. Okay. So how do you do sort of a dev prod kind of a thing with Compose? How do I do multiple environments and stuff like that? So, and that's where the concept of overriding services in Docker Compose comes in handy. So for example, here, I'm building an application which will allow you to spin up a Couchbase server, which will have a Wildfly instance and make them talk to each other. It will have a Java EE application deployed on Wildfly, and that Java EE application will pull the data from a Couchbase instance and display using REST. Okay? So this is how my service is defined. Now, the key thing here is I have a container name db-dev. I have an image. I have an environment. I'm giving, remember I'm using now container, not linking, but networking. So this is how my containers are networked. Imagine in the same directory, I have a production.yaml file. Okay? And in the production.yaml file, all I'm doing is I'm saying my Couchbase, this is a db-prod. It's a new container, completely new. I could even override the image name if I need to. I can override, that's legal, that's allowed. And then in my Wildfly, I'm overriding the environment, saying, hey, by the way, the Couchbase URI is not db-dev, it's db-prod. And the port, instead of 8080, I'm making it 80. So you have these two files, production.yaml, and the way I'm going to run it in production. The first one is docker compose up-d is purely for development. And in the bottom case, I can run it in production by saying docker compose up-f docker compose.yaml. That's my first file. And the second file, I can say -f production.yaml. -d. That's it. So just two different commands. So that way, you can have multiple Docker compose files, one for dev, one for CI, one for staging. You can point to different databases. You can have URLs. You can have ports, whatever you want. Two down, four more to go. Now, important part to understand is Compose in production is not ready yet. It can be used for lightweight production environment, for dev, staging, CI, but not really for production in that sense. So it's not suitable for larger deployments in that case. Okay, let's see if there are any questions before we jump into Swarm here. Is there a solution for teams that develop on Windows? Now, ask Microsoft that question, but the understanding that I have is, in 2016, they will have support for Docker natively on the Windows box whenever the server gets released. So that's one part of it. Now, Azure support Docker containers as well. So Docker containers can be very easily provisioned on Azure. Docker machine definitely is one of the things that you want to look at. That really simplifies development over there. Particularly with Docker Compose, I was saying, we had nightmares having Docker Compose running on a Windows machine. I've heard good comments since Docker 1.9, so that's the positive thing to look at. And file a bug. Okay, well, one thing I want to share here. So if you go here, all the slides, and I truly believe, I stayed at Red Hat for about a couple of years, but two things that I really picked up from Red Hat. One is the more we share, the more we grow. The sharing part, which I really took to my heart. Sharing is very, very important. Second is transparency. Whatever you do, you share with the world. So here, in that sense, all the slides, all the code, everything is checked into this workspace here. So this is the GitHub URL. So what I want to do, what I would help is if you can file an issue here that, hey, write a blog or write a chapter on Docker on Windows. So I'm happy to do that. So this is what give food for thought. Okay, let's see what else. Okay, there's a tip already. If you're using Docker on Windows, what do you do? Networking allows, yes. Software-defined networking, 3 more notifications. Yes, what about running 2 MySQL servers on port 3306 in a networking approach? So that's one of the issues I was talking to the Docker team over the weekend. Docker Compose is not ready for production yet. So the scaling, and literally I got pulled into a bug or a discussion yesterday with the guy who's responsible for Compose/Swarm. How does that work? I mean, if I want to scale, now I want to scale my MySQL. Well, one of the things we didn't get to talk about in Docker Compose is you can scale your services. You can say, hey, Docker Compose, scale. Remember, there's a MySQL DB and a MyWildfly service. I can say scale MySQL service. Spin up 2 more containers. Particularly in the case of Docker networking, that's not very well supported in Docker Compose. So this is still a TBD. I've been pulled into a discussion yesterday, so we'll see how that goes along. Well, this is the same question, why Docker Compose is not suitable for production. And it is actually listed on their website. Yes, in your example with networking, can the DB be started? And I think that's one of the benefits of networking. Yes, the DB can be restarted. Remember, it's a container. So don't think in terms of restarting. Think of in terms of diapers. Throw your diaper, put on a new diaper. And remember to do the volume mapping so that your data doesn't go away. One more. All right, let's talk a little bit about Docker Swarm. So I think up until Docker 1.4, they didn't have, it was a single host solution. Docker was a single host solution. In 1.5, I believe they introduced Swarm. So what is Swarm? Swarm is a native clustering for Docker. It basically allows, it gives, let's say you have a whole bunch of Docker machines running, or Docker hosts running, and you want to deploy your application to those hosts. That's when you take a whole bunch of those hosts and you create a cluster for those hosts. It provides a unified interface to a pool of Docker hosts in that sense. Fully integrated with machine and Compose, and that's how I create my Swarm clusters. I will create a machine, and I'll say this machine needs to be part of this Swarm cluster, and that's a very intuitive command. That works very well. You can run a Compose, and you can target that Compose, which is basically an multi-container application, to a multi-host cluster, and that works. One of the beauties of Docker Swarm cluster, it serves the standard API. What that means is, if you had a Docker CLI, which was talking to a single host, the Docker Swarm cluster serves exactly the same API. And the advantage of that is, because it's serving the exact same API, your tool continues to work exactly the same way. You just change the environment variables. Not just the Docker CLI, but there are a whole bunch of tools around Docker ecosystem. They all continue to operate in the same way. So that's the beauty of it. They all, whether you're working on a single host or a multiple host, because they're both serving the same API, single host or Swarm cluster, your tools don't have to change. Now, 1.0.0, they say ready for production, and this was literally announced last week. I have my doubts on that, and they've stress tested again, Swarm can be done on multiple clouds. They stress tested on 1,000 EC2 nodes with about 30,000 containers. They seem to do okay on that, which is a pretty good number, I think. But the fact that Docker Compose and networking and Swarm are not very well integrated, that gives me my doubts. How would I run a multi-container application actually on Docker Swarm cluster in that case? How is that scaling is gonna work? The same question that one of the gentlemen was asking on the Twitter is how does that scaling work? So I think that to me is limiting. So Docker claims 1.0.0 ready for production. I have my doubts. How does this work really? So at the bottom layer, you have a lot of different agents where you're running your Docker hosts. So think of this either as bare metal or cloud or your laptop. It doesn't matter really. A whole bunch of those at the bottom where your Docker host is running. On each Docker host, you can run 1 or more containers. So that's cool. Now, you want to create a Swarm cluster. When you create a Swarm cluster, to begin with, when you create the cluster, it needs a cluster ID. and that cluster ID needs to be retrieved from a service. On the top right, what you see are the different services that are available. If you don't give it a service, by default, it picks up the Docker Hub. It talks to Docker Hub, gives you a cryptic cluster ID, and that's like your sort of Willy Wonka ticket. You hold on to that, because that number is not, you cannot query the number again. You cannot ask for the list of Swarm clusters you have created. So if you're using the default hosted discovery service, hold on to that magical number. But otherwise, well, that's only for development though. In production, it's highly recommended to use something like etcd or Zookeeper or Console, set that up, and then use that for your production. So you query your service, and then that service will give you an ID, and then you can build whatever protocol you want to build, but use that cluster ID for creating your Swarm cluster. So that's how the machines are discovered. That's how the cluster is maintained. Now, once you have got the token ID for the cluster, when you're adding new machines to the Swarm cluster, every time you add a machine, you give that cluster ID. So, hey, by the way, this machine is part of this cluster. So you can have multiple clusters if you need to, spanned across multiple machines. But a host can belong to a cluster. A host cannot belong to multiple clusters. And at the bottom here, it shows also overlay network. We'll talk about that a little bit later. Now, when you're creating a Docker machine, at that point of time, you can advertise the Docker machine to be part of a cluster. You can say, hey, by the way, this is well, you have to give the token ID, but in addition, you can say, here is a cluster store that I'll be talking to, which is either etcd or Zookeeper or whatever your idea is. One of the cool things well, I don't think we talked about that. Okay, when we create a Docker Swarm cluster, there is a single manager or a Docker master, and there are a bunch of nodes. Master is purely for administration perspective, and there are a bunch of Docker nodes or Docker hosts where you're running your containers. Master is only for administration, but is that a single point of failure? No. And there's a process by which you can have multiple masters, and that's what master high availability is about. So it handles the failover of a manager instance if the Docker manager fails for some reason. There is a primary manager, whichever you create first becomes the primary manager, and you can have multiple replica instances. So primary and replica is the terminology that Docker uses. If a container for some reason, if a host for some reason makes a request to replica, it is automatically proxied to primary. Hey, primary, you serve it. Everything has to be done by the primary. Now, how do you create a Swarm cluster? Swarm cluster by itself, Swarm by itself is not a CLI, it's a Docker container. So you say Docker run Swarm, and you run a Swarm cluster. That creates a Swarm cluster for you. And the way you manage it is, with Swarm, you can give a parameter like manage. So you can manage the cluster that way. And these are some of the options by which you can achieve master high availability. You can say a -- replication, which basically enables manager replication. By default, it's not turned on. You can have some TTLs over there, and then you can say address of a new Swarm manager that is joining, the set of managers. So that functionality of manager not being a single point of failure exists very clearly as part of Docker. Now, how do you figure out, I have a Swarm cluster with a bunch of nodes in there. How do I figure out where my container is going to be running, which node is going to be running on? And that's called as, how do you do the scheduling in the backend side of it? There are 3 parameters primarily, based upon CPU, based upon memory, based upon number of containers, and that's how Docker figures it out. So for that, or you can create a custom strategy, Docker machine create dash, well, I'm sorry. When you are, I'm sorry, this is the wrong, it should be Docker dash machine. When you're creating a machine, Docker machine, at that time you say create, you can say dash strategy, and to the strategy, you can give it a value, that what the strategy is going to be. What that value could look like, by default, is spread. So that means you have a Swarm cluster, and in the Swarm cluster, you are creating a new application. It's going to spread the container across all the hosts. It's going to make sure it's going to operate as if you want to have the least amount of container running on a node. And that's the strategy it's going to use. The second strategy is going to be bin pack, where it's going to say, hey, I'm going to pack all the containers on one node. That gives me high density on a node, and it also allows me to run heavyweight containers on a separate node as well if I need to. And then there is a random strategy which you want to use for debugging. Think of it as a chaos monkey, where you can say, hey, I want to run my container wherever they can, and then I'll pull that host down and then see how that happens. Another cool thing here, yeah, those are the three strategies. API for pluggable backends, where what the strategy is going to be. For example, I want to use Mesos as my pluggable scheduler. That API is coming, not there yet, but coming. One of the questions that people ask all the time is, how do I limit sort of a CPU/memory resources? So I talked about -C, -M. -M is basically how you constrain the memory, that this container should never go outside that much memory. If it goes, just sit there or die or whatever that is. This talks about how do you limit CPU resources. The algorithm for CPU resources, you have to think about it a little bit. There are multiple switches, and then they cooperate with each other. But the one that I want to highlight here is -C, which is basically CPU shares, the very first one on the top. So effectively, let's say I'm running 3 containers, and these switches can be specified at runtime when I'm running, or even in the Docker Compose file as well. Now, when I'm running a Docker container, at that time, I can say Docker run -C, and I can give it how much share I want. Let's say I have 3 containers. To the first container, I say 1024. To the next 2 containers, I say 512, 512. And they're going to be given, the first step you want to understand is the CPU is equally shared based upon 100% running capacity of the container. Let's say you built a container that is 100% going to suck up the CPU. Okay, so let's say we build 3 containers like that. Now, and if I run those 3 containers, in the ideal condition, the first container, which is 1024, will be given 50% of the CPU. The next 2 containers will be given 25%. Now, if I'm running 1 container only, and there are other containers running at the same, the other container are running, but they're not doing anything CPU intensive, the CPU can be borrowed. But if those containers start up and they have a certain priority, then the CPU cycles have to be given back to that container. So it's a little bit cryptic, but you need to understand it, how that works. So how do you get this machine plus swarm plus compose, all of that working in there? So this is the same diagram that we talked about. At the bottom, I have Docker hosts. I have multiple containers. I can create, these are created using Docker machines. I can destroy machines. I don't need to bring down my cluster. The machines can be added dynamically. Machines can be removed dynamically. All that can be done. I guide my application to this swarm cluster using Docker Compose, and that's okay. At the bottom, you can say how I have Docker Compose. I can bring up my application. I can shut down my application. I can start my services. I can scale my services. So all that functionality is very much available. Okay, let's switch gears and let's see if there are any more questions here. Ready for production. I would love to use that image next time. Okay, cool. All right, so another concept that I want to talk about is data volumes. We talked about it a little bit earlier. This is, again, a new concept introduced as part of Docker 1.9. So data volumes allow you to persist data independent of containers' lifecycle. I could use a map to my home directory, but that's okay. That's fun for development. How do I go into production? Three more. So, excuse me. So I have a command called as Docker volume. So I can create Docker volume, and that'll create a Docker volume for me. And again, to Docker volume, I can say --help. It'll show me, the full list of options. The beauty here is I don't have to create volume on my local drive. I can use plugins like Flocker or Ceph or GlusterFS and different kind of storage mechanisms. And I can say, create a volume on a different device altogether. That's what those storage tools are meant for. Use them for storage. And I'm just going to use that volume. I'm just going to use that volume when I'm running up my Couchbase cluster or my MySQL database. I'm going to use that for volume mapping. So what I do is I say Docker volume create, I give it a name, and I say data. And when I'm running my container, all I'm saying is, hey, by the way, just use that data volume. And I know when I'm running my Couchbase cluster or Couchbase server, the data is stored in OPT Couchbase var, and I'm mapping it to that volume here. So very simple. And then the plugins, etc., all are available as well. Let's talk a little bit more about network. So Docker network, that's the new command that is introduced in Docker 1.9. It allows you to create multiple networks, and when you're creating a network, you can create bridge network or overlay network, as we talked about. Bridge network is single host, overlay network is multiple host. Overlay network has some requirements. We'll talk about that in a second. But the way how Docker Compose and networking work with each other is, let's do this actually. So what should I do? Okay, let's make a temp directory here. And I'm going to call it a docker compose.yaml file. Okay. And in this file, all I'm going to say is my wildfly. And I'm going to say image is jbus/wildfly. Okay. So I'm going to do this, and I'm going to say ports. I'm going to say 8080:8080. Okay, so that's cool. So now move it to the temp directory. Here you go. It's always a good idea to put your Docker Compose in a directory, because remember we said context. I was with a customer last week, and they put their Docker Compose in the home directory. It's okay. And then he says, hey, by the way, when I do Docker Compose up-d dot, it takes forever. So why? It says, why does that happen? Well, that's your home directory. How big is your home directory? Because that's the context Docker needs to read. So it's always, always important to put your Docker Compose in a separate directory. You don't want to read your entire home directory as a context. You probably don't want that. But here, I have Docker Compose. So I'm going to say Docker Compose up-d. Okay, if I do that, oh, port is already allocated. So okay, so we can shut this guy down here, and we go here and we run it. Ta-da! So that just fired up my Docker container here. Okay, so now I can say Docker Compose logs, and it shows my logs. That's pretty cool. And each log is, if there are multiple services running here, it'll be prefixed with that. I can say Docker Compose PS. It shows me my containers, which are running here, the ports, etc. I can say Docker Compose -- help. It shows me the complete set of servers here. I can say Docker Compose stop. It's going to stop my server. I can say Docker Compose rm-f, or just rm. It's going to remove my servers. It says, hey, do you want to remove the server? Yes, I do. Server is gone. So Docker Compose, in that sense, has all the command line switches options that are available for Docker otherwise. Okay. So now the thing that I want to show you here is, if I say Docker network -- help, it shows me the list here. Now I can say Docker network ls. By default, these 3 networks are created, and this is a funky one, none null. I filed a bug for that already. So I don't know what does it do, but that's sort of the default bridge that consists, and I don't know what does host do. So anyway, what I'm going to do is, I'm going to say Docker Compose. I want to do up-d, but instead of running it into the default bridge network that it creates, which is Docker 0, I want it to, well, I want to show you something here. I want to run it in a separate network. And the advantage of running it in a separate network is it's sandboxed. Even though it's a bridge network, but they're all separate networks by themselves. So if I want to run a Docker Compose application, which is in -- x networking, one of the questions earlier was, why Compose is not ready for production? It very clearly marks here in bold letters. First of all, it's a -- x networking. So X gives me a flavor that is purely experimental. They're just playing with it. And well, voila, it says big bold letters experimental. So it's not for production in that sense. But the part I want to do here is, I'm going to say Docker Compose up-d, but I want to run it in its own bridge network. So if I do this, and that's a bug that I filed as well. It says TMP with driver none. That's not true. But now if I say Docker network ls, oh, sorry, docket, go read the command. Now when I do this, my TMP network is created, and it's a bridge. It's a bridge network. So now it's running automatically by itself. So that's what this slide talks about. So remember this slide we talked about how we have a whole bunch of Docker hosts running at the bottom, and I'm creating a Swarm cluster. They are talking to the different services for the cluster ID, which is the recommended for production, and the Docker CLI is talking to them. Let's see, how do I run it in a multi-cloud environment? What is the advantage that overlay networks gives you? And that's exactly the point of overlay network here. So I want to run a Docker application. I want to run, not Docker, but I want to run my application across multiple clouds. And let's say I want to run it in Google Compute Engine, Azure, EC2, and DigitalOcean, okay? So on the bottom right, what you see is my Docker Swarm cluster. Because it has to be multi-host, so it has to be Docker Swarm cluster. So I'm going to create a Swarm cluster. And once I create a Swarm cluster, I need to have a hosting service going into production. So I'll have a hosting service where it's going to get the token from. So once I get that, I'm creating my Swarm cluster. And remember, I can specify multiple virtualization providers. So I specify those virtualization provider, and I'm creating those different Docker hosts. Well, I mean, each of these provide Docker support natively as well. So once I create Docker hosts on these different containers or different cloud providers, then I can build an overlay network on them. In order to have an overlay network, I do need a service which says, oh, you need some sorts of truth, how these cloud providers are going to talk to each other. So then I build an overlay network using that service, and that could be, again, etcd, console, whatever you want to do. But once you build that overlay network, then I can deploy my application on this overlay network running in a multi-cloud. So this is a true multi-container, multi-cloud application. I can have any app on any cloud talk to any database on any cloud, and that's the advantage, and that would work. So Alexandre Beselic, who is the lead for Docker Swarm, he showed this demo, I think at a meetup in San Francisco last week, and there is a meetup that is happening tomorrow, Docker Online meetup that is happening tomorrow or day after. He's going to show this as part of that. Now, I'm part of an exclusive Docker Blogger program, so as part of that, we get an exclusive preview before this thing goes live. So, but this was very, very impressive. All right, so I think in that sense for Docker, these are sort of the main points here. All the content, as I said, is available on github.com/JavaEE samples. It says JavaEE samples, but by no means is restricted to Java EE. It's a pure Docker Java thing. And again, it's not restricted to Java. You can use it for any language. The Docker docs are just outstanding. I file bugs on them all the time, but I absolutely love the docs. How easy, how simple, and they are the authoritative source. The cadence with which Docker is moving is really good, and in that sense, docs become the really authoritative samples. Yeah, but yes, we can definitely use more samples there. All right, let's look at the questions here. All right, not bad. All right. Any questions in the room before we jump onto the Kubernetes part?
Is there a way to take latency or speed into account when creating overlay networks?
Overlay network is a pretty brand new topic. I haven't played with it yet. It was literally introduced, like as I said, last week. Yeah. And I don't think that's related to Docker in any sense. Would that be?
Well, it's having the database on one side of the world and the application on the other would be.
Agreed. And so that's not a Docker question, in my opinion. That's more like, how do you architect your application? The question was, how do you reduce the latency in an overlay network? So that's not a Docker question, in my opinion. That's like, yeah, you just run different zones and the way you structure it. So, yeah, sure. All right. Since there are no questions, we'll keep rolling. All right, you know my introduction, so I'm not going to go through that again. What is Kubernetes? So now we learn all the concept of Docker. So that's good. We understand the basic concept of how Docker works. What is the image? What is the container? Docker Swarm, sort of ready for production. There is Docker Compose, which build a multi-container, multi-container application. All those things are good. Kubernetes is an open source orchestration system. They hate to use the word Docker, but they say for containers. But Docker is the only container that we use, and I don't know. How many people use Rocket in production today? No hands. Yeah. That's pretty much my experience as well. Now, there is an initiative called as CNCF, which is they're going to create a common connector, common container definition. So that's cool, because then Docker would be compliant with that. Docker is part of that. All the guys are part of that. Then anybody can create container as long as they're compliant with the specification. So open source orchestration system for containers, but Docker is the primary container that I've seen around. Now, this is built on Google's experience of Borg. They've been running, Borg is their internal system, which is what they've been using for years, for the past 10 years or so, for running containers inside. So they definitely have the scale and the experience. But one thing to understand is Kubernetes is a brand new source code. So they have the experience, they know how to write the source code, but it's a brand new source code. So there are bugs, and there are features that they need to add. They're not just taking that existing source code and putting it outside. There are pros and cons, both the sides. I'm not saying anything. I'm not passing a judgment here, but just something you need to be aware of. So what's the cool thing about Kubernetes? Well, Kubernetes gives you declarative primitives, or it gives you, it says, what is the desired state of an application? So the desired state is, I want 5 containers running. Kubernetes will make sure those 5 containers are running for you. It is truly multi-host in that sense. If you want to run those 5 containers, if any container goes down, I'm going to bring up a container. If some other container pops up somewhere else, I'm going to kill that container. I'm going to make sure those 5 containers are keep running. So in that sense, it's self-healing. It automatically restarts the container if they go down. It can allow you to schedule across multiple hosts. And there are concepts in Kubernetes which allows you to replicate and scale the containers. That concept in Kubernetes is very powerful, and I've really found that very useful. So there are pros and cons in that sense. Docker is not a competition to Kubernetes. Docker Swarm is a competition to Kubernetes. That's what you want to think about. People say, you can't run Kubernetes without Docker containers. So yes, you need Docker containers to run Kubernetes, but do you need Docker Swarm to run clustering? Not necessarily. You can use Kubernetes for your clustering solution as well. Just use a plain Docker containers. So we learn the concepts of Docker. So we get that part. Okay, so we have a basic understanding of Docker. So let's learn some basic concepts. Now, for people who are starting new, the concepts may be a little bit overwhelming. There's too much layering that happens. Like, what is a pod? What is a service? What is this? So there is too many layers sometimes, but I think it's really thought through well in terms of going for production in that sense. So pod, in that sense, is a co-located group of Docker containers that share an IP and a storage volume. Containers don't run by themselves. The containers always run in a pod. Each pod is given an IP address that is ephemeral. Because today is running on a node, tomorrow it might be running on a different node, then it might be running on a different node. So there is one of the requirements for Kubernetes really is each pod must be given, or each resource, so to say, in Kubernetes must be given a unique IP address that is addressable within the cluster. Not necessarily outside, but within the cluster. So in that sense, each pod is given a unique IP address. Now, pod IP address is ephemeral. So how do I, fire up a JBoss pod, like 2 JBoss pods, and I make them talk to each other. Well, that's where the concept of service comes in handy. Service is a single stable name for a set of pods. You might be having a JBoss pod running and another JBoss pod running. You wrap them, so to say, in a service. And in that service, service is an IP address. It's a logical name, but an IP address, more importantly, that is addressable across the cluster. So for example, if you have a JBoss pod running and a JBoss pod want to talk to MySQL pod, you cannot talk to a MySQL pod, but today is one IP address, tomorrow it will be a different IP address. Okay? So then you wrap that MySQL pod in a service. The JBoss pod then talks to the MySQL service. And we'll talk about other abstractions which simplifies the relevance of service as well. Everything in Kubernetes is organized using labels. So you can say, here's my JBoss pod coming up. It is given a particular label. My service, how is going to find out that pod is part of this service? Again, done through labels. We haven't talked about replication controllers yet, but we will go to replication controllers. But everything is given a label, and those labels, in that sense, are stored in etcd. Etcd is purely meant for Kubernetes internal use. Don't try to jam your configuration data in there. That's one of the design patterns I've seen otherwise. But effectively, that etcd is nothing but a distributed watchable registry. So in that, for configuration data, so anytime a pod goes up, anytime a pod goes down, or a service goes up and down, service is basically a REST resource in Kubernetes language. And in that sense, is looking for those labels that you care about. A pod goes up, service says, hey, this is the pod, this is the label that I'm looking for it. You happen to be the pod, I'm going to pull you in. Now, that's cool. How do I scale my services in this case? That's where replication controller comes in handy. Replication controller allows you to specify how many pods you want to run. Think of it as a cookie cutter recipe, and we'll talk about that a little bit more. But so pod, ephemeral IP, logical containers put together, service, which is a fixed IP within the Kubernetes cluster. Labels is how service and pods connect with each other. And finally, a replication controller, which is how you, replicate your services. So quick time check. Was there a break scheduled in between? Yes? About now? OK, let's take a 10-minute break, then we'll resume back again. All right, let's take a 10-minute break. Are we live? Oh, cool. Excellent. Thank you. Thank you. When people come back from break, that's always a positive sign that, hopefully we have done a few things right. Not the whole thing right, but a few things right. Excellent. Thank you very much. So for people who are joining us after the break, or who were not there earlier, so far what we have covered is basic Docker concepts. So that was the first half of the presentation. We talked lots of Docker. One day I've been thinking I'll probably do like Steve Ballmer, running from this end of the room to the other end of the room, jumping Docker, 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 Docker. I'll probably do that one day. This half of the presentation, we have started with basic Kubernetes introduction, but we'll start deep diving more into Kubernetes. Some of the concepts that we explained earlier was, how there is a pod where you can run a container. So you don't run the container by itself, but you run a container inside a pod. Then pod is an ephemeral IP, so you can't really access it. You can access it, but it'll die and it'll run on a different host. Then you want to run a service in front of a pod, which is a static, not a static IP, which is a referenceable IP in Kubernetes cluster. And service has multiple pods underneath it. Service also acts as a load balancer over there. Labels is how you organize all these services and pods together. You say, this pod belongs to this service by labels. Those labels are stored in etcd, which is a distributed watchable registry. And the way you scale your service is by having a replication controller. And to the replication controller, you say how many replicas you want. And replication controller is nothing but a cookie cutter recipe. Some more components here. There's a concept of node. Now, in terms of Kubernetes, again, it's a true multi-host clustering solution for Docker containers. So you have a master, and then you have a node. On a node, you run a Docker host, of course, but in terms of Kubernetes, you run something called as kubelet, which is also the node agent, and which is responsible for coordinating with master on what needs to happen and stuff like that. This is also the one where which serves the Kubernetes API. So there's a Kubernetes API server running over there, which then communicates with the master. By Kubernetes API server, I mean everything is done using REST once again. So that's how things happen here. Now, if kubelet is a node agent, who monitors kubenet? So in that case, if you're running on a Debian system, there is Monet, or if you're running on CentOS, then there's systemd, depending upon what flavor you're running it. And those are basic core operating system itself. Master is sort of a single master, which is purely from administration perspective. So there's a master, and then there are a bunch of nodes on which the containers are running. And I'll show a more detailed diagram, which will helpfully explain it more. And then there is etcd, which we talked about, which is sort of my distributed key value store, and is watchable as well. So different services can watch for what nodes, what labels are being added or removed. So I'm going to go back to, as I was saying earlier. So as you see here at the bottom, there is my Twitter handle, Arun Gupta, and #Devoxx. Those are the two things that I'm looking for here. So if I go back to my thing here, and I see what new notifications are there, is there a way to take network speed limitation into account? No, so I think as I talked about it, that's more an architecture questions. Do you only file bugs, or do you create pull requests as well? Both. I love doing both. As a matter of fact, I am working with the Docker team and Kubernetes teams on different aspects. I've contributed samples to Kubernetes, and I love doing both. Hey, we live in the open source world. Any contribution, any bug, any doc, any blog, everything is a contribution. How do you manage security across clouds between Docker containers? That's again an application concern. I don't think that Docker brings anything new to that. Use Kubernetes with Docker Swarm or Docker directly. Kubernetes and Swarm are direct competitors in that sense. Swarm is a clustering technique, clustering for Docker containers, and so is Kubernetes. So you would use one or the other. I have a table that I will show towards the end of the session where it directly compare and contrast Docker and Kubernetes one-on-one. So this question will be answered over there. Docker Toolbox and Kubernetes, glad you like it. What else? One more new notification. Okay, cool, back to job. So in terms of architecture, how does Kubernetes really look like? There is a master, there's one master. We'll talk about one or more master, but there is one master, and there are multiple nodes. On each node, there is a Docker daemon running. There's a kubelet running, as we talked about, which is what talks to the master. They talk to each other using the REST API. On each node, there are multiple pods running. Pods can have one or more container. We'll talk about that in a little bit as well. But let's talk about that now. One of the questions people ask all the time is, what is the relation between pod and container? The most common design pattern when I talk to my friends and developers and architects between pod and container is pretty much one container, one pod. That's what they're doing it. It says, yeah, logically related, they have their song, but most of the time I'm seeing, there are use cases, where you want to receive the request into one container, and then you want to forward it to another container. They're logically related, but most of the time when I'm talking to people, they're doing actually one pod per one container. Master today is a single point of failure. There is version 1.0, which is sort of a hack where you have to run a particular utility in order to get a multiple master. There is a cleaner proposal that is in the offing, which is what I'm looking at. So I wouldn't say it's a single point of failure today, because there is a hack that is already available and that is documented on Kubernetes website. But yeah, that's sort of the lay of the land. So today, if you look at Kubernetes, essentially there is one GRU, one big GRU, and the terminology that they've used for nodes is also minions. So you have a whole bunch of minions that you can run what your nodes are, and where you're going to run your containers. So think of as one GRU, bunch of minions. And in the code base, in the command output of Kubernetes, all over the places, you will see the term minion being referred. And that's sort of the history. The term was called as minion earlier, now it's called as node. As I talked about briefly, in terms of master high availability, is hack by running a pod master utility is actually described on this URL at the bottom of the screen. But there is a proposal which talks about hot standby, warm standby, active active. And those are very standard terminology. I won't go into the details, but that's where you can find all the details about master high availability. So how does it work? Well, before we get into this, let me show something here. Now, Kubernetes, again, it works using a virtualization provider mechanism. So if I want to run Kubernetes on my machine, I do that a few times a week, start up a cluster, shut down a cluster, stuff like that. And the way I look at it is, I need to give it an address. I need to tell what virtualization provider to use. So Vagrant is the easiest one. Vagrant, in that sense, creates VirtualBox machines for me. So that's sort of the approach that I'm looking at it. So the way you do that is you set up an environment variable called as Kubernetes provider. And in this case, it is set to Vagrant. And I've already fired up a cluster for us before the talk because it takes a while, because as default, as part of the Kubernetes cluster, it creates one master and one minion. Now, you can change a variable called as num_minions, and then it will create that many minions. So, but by default, it creates one master, one minion, and once it shows that, this is sort of the good message you want to see at the end. These are the different containers running on master, actually. But it says Kubernetes master is running on it. That means this is the IP address, which is serving my Kubernetes API here. It talks about the kube DNS and the kube user interface. So those are some of the tools that it exposes as part of the output. But once you see this message, that means this is a good thing. That means your Kubernetes cluster is up. But effectively, all you need to do is, once you set up those values, you say cluster kube up, and that's going to fire up your Kubernetes cluster. Now, several times, actually, I would say 1/3 of the time, not several times, but 1/3 of the time, I've seen where the Kubernetes cluster would not come up, and only because I'm only in the Vagrant environment, the cluster won't come up. So it's sort of unreliable in that sense. I've filed a few bugs, they've asked for logs, it's sort of a non-reproducible thing, so I don't know how to debug about it, but a few times I've seen the Kubernetes cluster not coming up. So, you got to be a little bit patient. And then, unfortunately, the only thing we can do with that is, delete the cluster and start it all over again. But here, if I go fire up my VirtualBox URI, or VirtualBox UI, actually, so you can see I have the Devoxx backup running, which is the image that we talked about earlier. My Devoxx image, which is my Devoxx, which is my Docker machine for Devoxx that we created earlier today. Here is my master running, and here is my minion running. Okay, so those are my VirtualBox images, even though it's using Vagrant, but underneath is still creating my VirtualBox images. Everything in Kubernetes, once again, is a resource. So you want to create a pod, that's a resource. You want to create a service, that's a resource. You want to create a replication controller, that's a resource. You want to look at a pod. You want to look at what services are available. Those are all resources. So the API is very RESTful in that sense. And kubectl is the script that controls the Kubernetes cluster manager and allows you to create those resources and query those resources. The command is basically issued to the cluster manager, and then it figures out what's the lay of the land, and then it returns the results back to you. So for example, you can say kubectl get, so it's a very REST API, pods or minions, and then it'll explain that to you. You can say kubectl create, you give it a file name. In the file name, you have the description of what needs to be created, what resources need to be created. It's a YAML JSON file, and then it creates based upon that. We'll look at several of those files. You can update resources. You can delete resources. You can, once you have replication controllers created, you can increase the number of replicas you want. So if I go here now, and if I say get pods, it shows me the pods. Oh, it doesn't show me the pods. Oh. Aha, alias minions is deprecated. Use nodes instead. Well, the pods are not running yet. That's why it says no pods here. But when I say node, it shows me the nodes. And the master node is not shown because the master node is running at 1.2. It shows me only the node on which the containers can be deployed. So that's sort of the node that is showing me here. Now, I can say, show me service. And the good thing is, I don't have to type the full word. I can just type the first two letters as long as they are uniquely identifiable. So I can say SE, and it shows me the default service that's running. So pod, minion. Similarly, I can say replication controller, which is RC. None of the replication controllers are running. So it's a very REST-centric API in that sense, and that's, I like it. All right, so how does the configuration file look like? So on the left, first of all, I'm showing a configuration file. Line 1 says API version 1. Line 2 says I want to create a pod. To each pod, then I can assign metadata. And the metadata is basically a name-value pair. Well, you need to give it a name, first of all. The labels are a name-value pair. And this could be completely random on what you want to create. It's a name-value. Whatever name, whatever value. I happen to use name, wildfly. So that's OK. Then to the pod, you need to give it a specification. What is the specification of the pod? OK, in this pod, I want to have these many containers. We talked about pod versus container. So typically one pod, one container. And in this container, what is the image you want to use? Here I'm saying, this is my Docker image. So that's sort of the Docker and Kubernetes connection you need to recognize. Kubernetes cannot run by itself. It needs a Docker container. So here I'm saying, I want to run the JBoss Wildfly image. I'm giving it that container a name as well. And by default, I'm saying, hey, these are the container ports. The important part to understand here is I am not exposing that port on the host. And that's not the recommended design pattern anyway. I mean, that is the recommended design pattern anyway. Because if you want to run multiple Wildfly and they're all exposing port 8080, only one can run. So let it be a container port. And I think that one thing Kubernetes handles really well in terms of networking and in terms of port exposition. That's really well done in Kubernetes. I love that part. On the right side, what I'm saying is, OK, fine, I run a single instance of pod. I can run a lot more pods, but they're not really allowing me to scale or deal with them easily if I want to shut them down or how they work with each other or create a cluster out of it. That's where you go to replication controller. On the right side, once again, API version 1, replication controller, metadata, spec. In the specification, line 8 says on the right side, I want 2 replicas. So in the replica, I need to give it a cookie recipe. So what is my template going to look like? Now, when I'm creating a template there, again, I can start putting some metadata. I mean, metadata is a very generic thing. You can pretty much associate at different places if you want to. And then finally, I'm saying spec, which looks pretty similar to what is on the left side. So kubectl create-f, giving the file on the left, which is basically a YAML file, will create my pod. kubectl create-f file on the right side will create my replication controller. We looked at this. We're using Vagrant as a provider. We looked at the VirtualBox user interface. So on the right side, what you see is on my MacBook, I have effectively a master and a node that is created using, those are 2 separate VMs, and that is all done using Vagrant. Now, Kubernetes also is a multi-cloud solution in that sense. So it can be provisioned on multiple clouds. What I've not been able to do that is if anybody is running production with multi-cloud using Kubernetes. Of course, if you don't provide the Kubernetes provider, by default, it tries to look for your Google Compute Engine credentials, and it tries to create your host and node and everything. I mean, master and node all on Google Compute Engine. But if you set the provider, it runs it accordingly. And so in that sense, the virtualization providers that are supported over here are these. You can also look at the complete list. Well, this is the complete list, as a matter of fact, which is actually documented on this get.k8s or K8s, K8s.io. I call it either Kubernetes or K8s. All right, so how do I run a pod with one container in that sense? All right, so I have my, well, first of all, let's look at the definition here. We looked at it already, API version kind. Kind is basically what defines what goes underneath in the YAML file, metadata, spec, image, and ports. Now, on my Mac, I have Kubernetes. Remember, master is purely for administration perspective. So let the master be there. On the node is where it's going to fire up my pod. And in the pod is where I'm going to run my Docker container, which is basically a Wildfly. How do you use services? Well, services is basically a set of pods put together with and they are exposed as a single IP. Service also helps in load balancing. So if the request goes to service, it figures out. There are some algorithms over there by which it figures out which particular pod in that service needs to be included. Remember, once we talked about service and pods are connected to each other using labels. Very simple. Now, the way service and pods work with each other, it does create environment variables. Kubernetes is, again, heavily environment variable driven. And it's like Docker links, but across hosts. And the most important part is the Kubernetes service is a stable endpoint for pods to refer to. It's an IP address that doesn't change. The underlying pods today might be running on one host. If it dies, Kubernetes cluster will automatically restart it. Could be on a separate host. But then the service is an IP address that is referenceable. And what that means is it will automatically play the DNS routing. It will automatically internally map the DNS for you. So I want to have a Wildfly service talking to a MySQL service or to a MySQL. End of the day, I'm a developer. I want to build an application which is going to be deployed in Wildfly and is going to be talking to a MySQL server. So how does that work? Well, I have a Wildfly pod. I'll have a MySQL pod then front-ended by a MySQL service. The container in the Wildfly container will talk to the MySQL service, which will then figure out where my MySQL pod is running. Remember, labels, that's what is being used. Today, one container is running for MySQL. Tomorrow, multiple containers might be running. It doesn't matter to me. I keep talking to service. So here is an example. On the left, what you see is I have a pod created, and into the pod, I have given certain labels. So I'm saying name and the context, because name is a very generic label in that sense. I'm giving it a context. And remember, we said the label is very user-specified. I'm using context. You can use foo : bar. That's perfectly fine. And when I'm creating a service on the right side, there I'm specifying actually the selector. In the selector, I'm saying, oh, by the way, I'm looking for any pod that comes up with this name value, which is name : pod, or name : MySQL pod, and this name value, which is context : Docker K8s lab. So it's just looking for that context, and then it'll just pull it as part of the service. Now, hopefully that is a MySQL server, and nobody else is using that context, but that's sort of the understanding you have to build. How do you do service across two nodes? One of the things that I have not played enough with, and I may not know about it, how do I well, I don't think you can do that. You cannot schedule a service on a particular node. That is not possible in Kubernetes, as I understand. But if a service, or you cannot ask that, okay, this pod must go on this node. I know there is a concept of affinity and constraints by which you can give some affinity that, okay, I want this pod to run on a machine with so much capacity and power, but on a specific pod, on a specific node, you can't say that, okay, this is a node here and you want to run it. You can certainly define labels for the nodes, and you can provide affinity that way, and that's okay. But you can't say on a specific node. But this is basically showing how service works across two nodes as well. So replication controller, as we talked about, allows you to run a specified number of pods, that many replicas are running at a given point of time. Pod templates are essentially cookie cutters. It takes that recipe, and if you say scale up, it runs that many. If you scale down, it just throws them away. Remember, we talked about containers being diapers, and if they are shitty, throw them, create a new one. It also allows you to reschedule them across multiple hosts. There is manual scaling, of course, so you can give, say, kubectl scale up, scale down, and there is auto-scaling capabilities as well, which could be metrics-driven. One of the ways that I've seen customers using a replication controller is, particularly with services, is for rolling updates. And the way you can use rolling updates is, let's say you have one version of the application, V1, that is running. You have a replication controller with a service in there, service, replication controller, and bunch of pods running over there. Version 2 is coming up, so you bring up version 2 over there. Same thing, service, replication controller, and thing here. Here, you start scaling down, and here you start scaling up, and then eventually all those containers are gone, and then you delete the resource, and this application becomes active for you in that case. So that's how I've seen people using services and replication controller. So this is what we've been talking about. Recommended to wrap a pod or service in a replication controller. Running pod by itself is like, you may want to do it for testing purposes, but it's a good idea to do that. So that's the point I made earlier. Sometimes the layer may seem redundant, but it does provide a level of abstraction and thought through well for production deployment. There are policies in Kubernetes that you can assign as part of the configuration file, that if the pod dies, automatically restart. You can actually set a policy that, nope, don't restart it. So you can override those policies. This is the default, where the restart policy is always. So how do we do replication controller? We actually talked about it already. Line 2 is replication controller. 3 to 7 is some context. Line 9 is the interesting one, where it says how many replicas you want to run. Line 17 is another interesting one. The way environment variables, and remember this was done a few months ago, so the way environment variables work in Docker and Kubernetes are different, or the way the environment variable names are created are different. So I had to build a custom image, one for working in Docker environment, one for working in Kubernetes environment. And that image that was working for me in Kubernetes environment was tagged as Kates. So on line 17 at the end, you will see K8S. And that's what the image identified. That, oh, by the way, this image is Arun Gupta Wildfly MySQL Java E7, but here is a tag that I want you to use for the image. So how does really replication controller work? Well, I have a master. A replication controller is nothing but a resource. And let's say I have a node 1, 2, and 3 where my JBoss pods are running. That's cool. So one pod, one container, that's cool. Now, we got that part. Let's say my node 2 goes down. Either the node 2 goes down or the pod goes down. One of the same thing, my application is not accessible. So Kubernetes will automatically reschedule it either on node 3 or on node 1, maybe on node 2. And you let Kubernetes worry about it. Depending upon the affinity, it will do the right thing. Scaling. Once again, you have node 1, node 2. 2 pods are running, JBoss pods are running, and there is node 3. And you say -- replicas 3. So you scale your application up. And here I'm giving the Wildfly RC is the name of the replication controller that was created earlier. Then you scale it, and it just scales it. And it just creates a pod in a new node, or maybe on the same node. It doesn't matter. Again, heavily depends upon the affinity and the way you have explained it. So that's pretty clean and simple. Well, one of the things I want to share here is sample production deployment. Okay, Daniel is a great friend of mine. They have been building Kubernetes in production. And that's what I'm going to talk about a little bit. It's basically an e-commerce optimization tool and monitoring tool which will help you increase your sales. So Daniel runs this company, Wombat Software, based out of Germany. So he and I were just talking because they are using Kubernetes in production. So I said, what does your typical deployment scenario look like? Here's what it looks like. And my animation is not working here. Oh, here you go. OK. So first of all, shoot, this is messed up. They were using 10 nodes. Each node is core OS. So remember, they're not, this is Kubernetes deployment. So they're using core OS, which can run containers natively. Each core OS node is 32 gigabyte RAM, 32 core and 160 gigabyte RAM. They're running 10 nodes like that. 10 nodes like that, and each node, the normal containers were 400, the peak containers were 600 for them. To begin with, they started running these core OS nodes on Amazon, but then they had to back it away from there. And again, this is pure core OS AMI, nothing to do with Google Container Service or anything like that. You can just pick a core OS node or a Ubuntu or a CentOS node, and you can run it in production over there. So they were using Amazon, but they had to back out of it because of networking issues, and I think pricing was the other part that he talked about. But now they are just leasing some machines in a local data center, and they're running it over there. So, and it's working well for them. So again, normal containers is 400. So if you were to size your application, again, the container is very specific to your application, how much CPU cycles, how much memory cycles it gives you, and stuff like that. But once you have sized your application, that sizing guide is very important. For them, 400 to 600 was a good range that worked out for them. Another thing that is available in Kubernetes is health checks. So you can restart a pod if wrapped in a replication controller. That works very well. So your pod never dies, basically. There are certain application-level health checks that you can build in. Those are pretty basic, in my opinion. It just looks at a HTTP status code, or if the container is running or not. Any application-level health checks, TCP socket, those are very basic checks. So it really doesn't bring anything new to the table in that sense. It's still upon your application on how you connect to the application and the kind of metrics that you expose. So that's an important part of it. One of the things, how do you start with Kubernetes? Well, you can download the tar.gz file. That's the easiest one. You can download the tar.gz file, you can untar it, you can set up the Kubernetes provider, then you can fire it up. Now, I found a document yesterday which says you can actually start Kubernetes using Docker. Okay, so what would that mean for me? So I said, it required you to start a few servers. I said, the moment I go +1 container, or even 1 container, I just make my Docker compose file. So I built a Docker compose file. And in that sense, it requires you to start etcd. That's one that we require for, remember, distributed watchable registry. Then we need a master, and then it requires you to start a proxy. So there were 3 here, and it's not the full Docker compose file, but effectively it's giving you the image name for each of those. It's giving you they need to be started in a privileged mode. So that's exactly what you can define in Docker compose file. And the Docker compose file is available over here. But I couldn't get to fire it up and test it out, but effectively, if I were to do this on my machine, I have a Mac OS X here. On Mac OS X, Docker is not supported natively, so I will run a Docker machine. So I will have a Docker compose file that will have 3 containers running in it. And in that master container, I'll have a pod in which I'll have a Docker container. So almost like your head starts spinning, I'm in an inception mode, where am I? Am I running in a Docker container? Am I running in a Kubernetes cluster? Or where am I? It kind of gets head starts spinning. So this is my tiny application controller and all of that plumbing built around it. By the way, this is the recommended starting point, as they say. So if you want to run locally, and if you go to Google's website, this is the recommended starting point. I have always found, I don't know why they couldn't create a Docker compose file for this. Instead of saying, no, start this, keep it simple, guys. I hate that whole aspect of NIH. Because this is a Docker compose file, no, we want to do it our way. Just make a Docker compose file, make it easy for people to do it. I'm going to file a bug on that. I have a Docker compose file already anyway. But to me, the easiest way to start with Kubernetes that I've found very helpful is I download tar.gz, set up the Kubernetes provider, and fire it up. And it's mostly reliable, and it works very well. A lot of people, when they're using Kubernetes in production, they are not using Vagrant. They are actually using hardcore machines, where Core OS, CentOS, and those are the operating systems that I'm seeing people are using Kubernetes in production. So these are my references. What I'm going to do now is I'm going to talk a little bit more about Docker and Kubernetes for the next few minutes. I'll keep talking about that. There's a lot more in Docker that we need to look at it. So what we're going to do is we're going to jump here. Oh, there's some questions. Let's look at that. I can't read this language, man. This is good, though. Something good, maybe. Does Kubernetes provide any tools to manage upgrades of your multi-container app, including data containers? Well, one of the things we talked briefly about data containers in the earlier part of it. So we talked about the rolling deployment aspect of it. Remember you have services, and then you have replication controller, how you can set up two services and start, do A/B testing, and once you have done A/B testing, then you start guiding your traffic to one service or the other, slowly scale one up and the other one scale down. So that will help you with that. Right, so I think this is a great point. Are you sure they are for Docker, Kubernetes? Are you sure they are for Java developers and not for system administrators? Yes, it is heavily a DevOps kind of a thing in that sense, but end of the day, you want your application to be run more efficiently, in a more dense way, in a more efficient way. And that's what Docker and Kubernetes really provides you. And those are some of the next things that I'm going to show you that hopefully you'll understand that, see, end of the day, when I'm an application developer, let's say God forbid I'm using Eclipse, but if I'm using Eclipse or easy to use NetBeans, or IntelliJ, how do I integrate from there? End of the day, I'm just writing a Maven project. Do I need to worry about all these details to going to Docker and Kubernetes and deployment and all that stuff? So I'll show you some of the tools that you will find useful in that line. Is there a performance overhead to dealing with a pod as an abstraction? Many are using one container per prod. Not really. I've not seen any abstraction. Remember, pod is just a resource with one container in it. So, there is really, you don't call a pod and then you call a container. It's just, a label. How do you save cluster your data with Kubernetes? My data is sometimes shitty. Oh my God, but still don't want to throw it away. Yeah, well, so the whole concept of, your volume mapping. Remember we talked about, how you map a volume and have data-only containers. So you set up a data container. So I agree, containers are diapers. You shit in them, you throw them, then you bring a new one. But you throw your diaper only with the one which is process is running, not the one with the data. And actually that does bring up a good point. Sometimes when you're running containers, you have to be really aware of it. The container, if you want to throw away the container but still grab the relevant information out of it. So how does that work? Well, that's where stacks like Elk comes in very handy. So Elasticsearch, Logstash, Kibana. So one of the friends I was talking to a couple of months ago, they do a lot of these, Kubernetes production deployments, but if they're containers, they have to throw them away, but they still need to extract the relevant information from it. So you don't put the logging information in the container itself. You put it in a central logging information, and Elk is just one of the stacks. So pick a stack that comes to your mind, or that is of your preference. I'm not aware of any tools to help with the rolling update. And I think Kubernetes is still new, honestly. It was announced at OSCON this year. So I think that ecosystem is going to build on top of it. Is there an overhead? We talked about that. Does Kubernetes replicate data for volumes between nodes? No, I don't think it replicates data. I've seen recipes, though, where you can look at how you can run MySQL in a master-slave configuration in the Kubernetes environment. So that's definitely something that you can look at in terms of scaling of data itself. Oh, one more. OK, so the next thing that I want to walk you through here a little bit is, this is the hands-on lab that we will try tonight, this afternoon, rather. All right, so now I'm an application developer. As an application developer, I build a Maven project, And in that Maven project, I want to just deploy my application. I do Maven clean package install. The thing goes to my Nexus repository. How does Docker fit into that environment? How do I build my image for that? And that's what this Docker Maven plugin is for. So it has this targets call as, which allows you to start, stop, build, push containers, or push images rather, not you don't push containers. But that's sort of the basic mechanism over here. I'm going to show you here. So let me clone this guy here. So I have my Java E7 simple sample. I'm going to fire up my NetBeans. Load. Thank you. So I'm going to open up my project here. Okay. So this is a very trivial project. I don't have anything fancy here. Just a person database. So if you look at my person resource, it's just a simple REST endpoint. Okay. So nothing fancy in there. Now, if I look at my project files here, though, that's where the fun is. I got a lot of information here because it shows you how to release the project, etc. Oh, not here. Okay. Sorry, wrong project. Oh, that one, yeah, okay. Sorry. Okay, that one. That project has the same files as well. Ta-da! So now if I look at my PALM XML here, this is very usual, nothing fancy here. All I've done is I've added a new Docker profile here. And in this Docker profile, for example, what I want to do is every time I do Maven clean package or clean install, I want to build my Docker image as well. So I'm using the Docker Maven plugin, a particular version here, and I'm saying, here is the name of the image that I want you to build. I want you to use JBoss Wildfly 900 final, and I want you to use this deployment descriptor to figure out rest of the details. Okay? So if I say assembly.xml, if I go here, in my standard Docker directory, like this is literally source/Docker directory in a Maven project. I have it here. I'm saying include this artifact, my group ID, my artifact ID, and which WAR file you want to include from the dot directory, and the dot by default resolves to target. From the target, it picks up that WAR file and includes it, and then builds a Maven image for you, or the Docker image for you. So if I go here, for example, if I say Maven clean install, okay. So this is my WAR file, okay. Now I can do the same thing now in Docker profile. And it says, hey, there is no Docker host environment variable. So we can easily fix that. We can say eval Docker machine env. Well, let's take a look at what the machine name is. It's Devoxx. Yeah. We can say eval Docker machine env Devoxx. Okay. So now if I look for Docker host, okay, so that's all good set now. So let's build this Docker image. And there you go. That's my Docker Maven plugin in action. I haven't built this project for a while, so hopefully it will build. That was my disclaimer. So there you go. Whatever intermediate images it needs to download, it'll take care of the complete life cycle for you. So effectively, you build that image, and then what you are thinking about is, hey, what do I do once I build the image? Do I store it here? You actually start pushing it. And remember, we talked about earlier here, it has the ability to push to a registry. So you can configure what registry you want to push it to. It could be a Docker Hub, it could be your private registry. So literally, as part of your development cycle, you can say, you know what, hey, Maven clean install, and something is being done internally, it'll automatically build. And as part of install for that sake, it can automatically push to your registry. We're still downloading. I think it's going to take a while. But I think that's sort of the thought process that I want you to think about. Okay, so that's Maven plugin 1. Now, one of the questions I was talking to some people during the break was, I'm using Eclipse. Okay, so as an Eclipse developer, I want to see how do I do remote debugging of a Docker container. Well, I mean, there is nothing new in there. When you are running your Wildfly in a Docker container, and if Eclipse or IntelliJ or NetBeans allows remote debugging, you just give it an IP address and a host, and it just connects to it, and you debug it accordingly. So there is nothing that you need to be aware of, that nothing that Docker brings into the picture that you're like, oh, what Docker is going to make this difficult for me. It's easy to understand. It just kind of fits right into your regular development cycle. Now, having said that, Eclipse has made it a little bit easier in terms of how well integrated Docker is. This is a contribution done by Red Hat to the Eclipse community. So it allows you to add a repository. Once you add a repository, you have to install Docker client tooling. But effectively, it shows you, it has a Docker Explorer now, where you can see the list of containers that are available, list of images that are available. One of the things we didn't get to talk about is when you are running a Docker container, you can look at, you can start filtering the images or containers that show me only this list, show me only that, and that could be a little bit fancy. So we're not going to go into that, but it allows you to specify all of that in a very easy and graphical manner here. So for example, here we are connecting to a Docker container or Docker machine. Then you make sure that your Docker machine is configured well. And here is showing you all the different images that exist on a Docker machine. Okay? And then you can start creating those filters that, okay, over a period of time, once you are building images, and you have run a container, the container stopped, the image got lost. So that's called as a dangling image or a dangling container sometimes. And there is plenty of those that happen. In production, typically people face issues where there are lots of dangling images and lots of dangling containers. So then you have to write like a cron job, which will automatically clean up those images. Because images, remember, we looked at Ubuntu image. Ubuntu image was about 188 megabytes. You add JDK on it, that's about 100 megabytes. Now you add Wildfly on it, that's about 100 megabytes. So any typical Java application, you're looking at about 500 megabytes of image. If you have a lot of those images running, it's a lot of space it could possibly take, or a lot of containers running that could possibly take a lot of space. So you need to be aware of that, then start cleaning up your images and your containers on a regular basis. These are about the images. These are the containers. This is a view of the container. Okay, so that's that. Now, if you're building a Java EE application, one of the things that you test them with is using Arquillion. Arquillion also has an extension called as Arquillion Cube. Now, the advantage of Arquillion is you don't take your tests to the container. It brings the container to you, and you run it. With Arquillion Cube, it does the same thing, and it says, hey, your application is going to be deployed in a Docker container. I'm going to bring the Docker container to you. You deploy it, you run it, and you let the Docker container go away. So it literally pulls it, you run your things in there, and you let it go, and it goes back. So there are details on that on this page where we talk about how to run Docker container, how to test a Java application using Arquillion Cube. It talks about that. We talked about Docker Compose, Docker Swarm, Docker Kubernetes. Okay. One of the things that I literally started working on yesterday, which I thought would be useful, is now I love ASCII-doc. I absolutely love ASCII-doc. I hate binary editing. I love text-based editing, and for that, I absolutely love ASCII-doc. So this workspace is all ASCII-doc based. So you can look at the chapters here. All the chapters are available over here. We'll always look for issues, pull requests, anything you can do to make this content better. One of the things that I started playing around with is, how do I compare Docker and Kubernetes now? So I said, okay, let me take a look at it. Docker versus Kubernetes. I want to build a document. People compare Docker and Kubernetes. You should not. You should not compare Docker with Kubernetes. You should compare Docker Swarm with Kubernetes. So that's, first of all, the first level set you need to understand. Because Kubernetes requires Docker. Kubernetes cannot work without Docker. Like people compare Spring and Java EE. Spring cannot succeed without the Java servlet container. So what I started doing here is I started putting some of the features that are relevant from a network perspective. And I think this is where I need the biggest help. If you can help populate what feature you care about for Docker versus Kubernetes, if you can send pull requests that, Arun, I would like you to investigate on this particular feature, I'm happy to work with Docker and Kubernetes teams to fill up the table. So file an issue, file a pull request, that these are the features we would like you to look at more. But based upon my limited knowledge so far, multiple master, Docker Swarm definitely makes it easy. They both have single master. So important part to understand is from the master perspective, master is purely from administration perspective. What that means is the containers are running on the nodes or your cluster. So if the master goes down for some reason, it doesn't matter. The nodes and the application is not affected. Only your administration part is affected. So in terms of Docker Swarm versus Kubernetes, single master, sure, both of them have single master. Docker Swarm, yes, very clear way of having a multiple master. Kubernetes has a status on version 1, which is sort of a hack, like running a pod master utility, but a more detailed proposal is explained as well. Multi-host networking, Docker 1.9 only has multi-host networking, which wasn't the issue. We talked earlier about the affinity aspect. If you want to run, container links were okay. They worked well, but they have to be on the same host. They did not work across multi-host. So that's one of the big things over here. They both provide multiple clouds. So you can run Kubernetes on multiple clouds. Similarly, you can run Docker on multiple clouds as well. Can you cluster across multiple clouds? I think that's the important part. Docker Swarm, definitely. And in this case, you have to use a cross-cloud network solution. So there are constraints. Dynamic scaling, this is a lot better here in Kubernetes. Replication controller works really well. I've been pleasantly surprised with it. Not surprised, but pleasantly happy with it. In terms of dynamic scaling here in Docker Swarm is Compose services. So remember we talked about Compose has multiple services. You can scale up and scale down, but it's not very well integrated with networking. So it's kind of a half-baked feature in that sense. In terms of container distribution strategies, we talked about spread, how it's going to spread in terms of Docker Swarm, how it can spread the containers across the cluster, or it can binary pack it into one container, or it can pick a random node where it's going to run a container. Yes, those strategies are pluggable in, there are similar strategies in Kubernetes as well. Are strategies pluggable? Yes, but the APIs in both the cases are unfortunately not very clearly documented. At least not in case of Docker. Kubernetes, I haven't investigated for a couple of months now. In terms of development, they say Docker, in terms of Docker, if you want to do development, Docker machine is clearly the easiest way, particularly in a Mac or a Windows box. Here is Vagrant. Although they say you should use a Docker machine. So once we get into that inception phase. Service discovery, this is again sort of partially baked up in Docker Compose. We looked at how in Docker Compose I had a container underscore name where I'm specifying my DB, dev or prod, whatever it is. And then in the application controller, I'm pointing to that service. And I can scale that service up and down, which doesn't work very effectively right now. In Kubernetes, again, is very well thought out and works very well. So the service discovery mechanism works very well. So in that sense, it does make Kubernetes as a very good platform for running your microservices. Commercially supported, Docker Swarm, From 1.9 onwards, yes, it is. But before that, it was 0.4.0, and it was very clearly recommended, don't use in production. Kubernetes has always been, since 1.0, commercially supported. Affinity, in terms of the way it works in Docker Swarm, you give labels. You give a node a label, and you say, hey, pod, you go to this node with this label, and that's the way it works. Affinity in terms of Kubernetes is using pods. So you say, which are the pods, the containers need to work together, put them in a pod, so to say. Constraints, again, in Kubernetes are labels, heavily labels driven. Constraints in case of Docker are like -C, I want this much CPU, or I want this much memory, and it'll restrict within that. So that's sort of the mode in which it works. Now, one of the things people ask me all the time is, so what are you seeing in production? Well, I attended a webinar by Docker about a week and a half ago. So they have customers who are actually working, who are using Docker Swarm in production. And I've met somebody who actually using Docker Swarm in production for actually 0.300 release onwards itself. So they've been happy with it. Kubernetes, I know a few people who are using it in production. I know a lot more people who are using mesos in production, though. That's for high-scale deployments. I was reading an article a couple of days back, and it said very clearly that don't use mesos for a low container deployment. It's definitely targeted at a high-scale deployment. With containers, you can run container is like a kettle. It's not like a pet. If you want to have a pet, then you're going to take care of it. That's your laptop. Containers are like a kettle. It's like one comes and the other goes. You don't even know. They all have a number. So in that sense, mesos work very well. And Mesos is a very low-level framework in terms of containers, if you want to think about it. But Mesos has this scheduler, pluggable scheduler mechanism which you can use to schedule your containers. So one of the primary way Mesos work is using Marathon scheduler, for example. So Marathon is their, again, framework by Apache Mesos, supported by a company called as Mesosphere. So you can say Mesos plus Marathon is what I'm going to use for my container solution. There is also a pluggable model by which you can use Mesos plus Kubernetes. Say, hey, I'm going to use Kubernetes for my scheduler. Mesos is a lot lower level primitive where you can say, here's a pool of resources that I have available. That Mesos is going to make you an offer. Hey, I have a machine available which has 16 gig of RAM or 40 gig of RAM and this much CPU processing power. Do you want to avail it? So yeah, sure. I'm going to run my container on it. And then you do that contract negotiation with Mesos, and then you run your containers on it. And then that combination with Kubernetes could be pretty killing. So that's another thing I wanted to highlight. Let's go back to notifications here and see if we have any more questions. Otherwise, we can maybe start wrapping it up. Okay, people like the speech. That's good to know. Is it forbidden to access the surrounding host from within your container? Is that for, networking. Okay, so this is probably Docker networking question, okay? Surrounding host from within a container. Not a good idea, I think, in my opinion. So the question is, in terms of networking, is it forbidden to access the surrounding host? So, you have a host on which you have a container running. Do you want to have the access from host to the container to be able to access the host? Not a good idea, in my opinion. Anything that you want to do probably using mounting a volume, like if you want to store the data. So I think that's the recommended way, in my opinion. Yep, NetBeans is my IDE. I love NetBeans. Yeah, so the question is how to continue with CI/CD after pushing your Docker image to your private registry. Literally, there are tons of demos that are available. If I go here, as a matter of fact, this is one of the slides I wanted to show. I started working on it, and it basically, let's bring it up. Oh, it won't show it because it's hidden. So let's say slide, and don't skip it, and show it. This is one of the demos I started working on. So for example, as a developer, I'm doing a git push. Okay, I'm doing a git push. Everything should happen from there. So if I do a git push, it goes to git server. Jenkins should trigger, pull or poll or hook, I don't care. but then Jenkins should really orchestrate my CI/CD pipeline for that. And Jenkins has a lot of plugins for that. I mean, I've been particularly playing with Jenkins in terms of workflow, which is a groovy script. I was talking to some folks earlier today. They're using heavy usage of workflow to build their CI/CD pipeline. Each of these, checkout, build, run, test, Docker image, these are all running in separate processes. And end of the day, in terms of CI/CD pipeline, what you're thinking about is, as I do a git push, it should run all the tests. They could be running on a separate Docker container and doing all of that. Remember, we talked about Docker Compose, and we talked about overriding files and stuff like that. You can use that to spin up your application and integrate that with Maven in there, and then you create a Docker image and push it to a private registry. That's where you want to do your testing, and once you have done that, then you say, hey, I'm ready. I've done all my testing. Let's push this image live. And you don't have to worry about all of that. OpenShift, which is Red Hat's open source platform, it has solved that really very well, actually. OpenShift version 2 was using a proprietary native kind of a gear kind of a terminology, but with OpenShift v3 is 100% based on Docker and Kubernetes. So it uses Docker as a container technology, Kubernetes as an orchestration technology. So you bring, and you don't have to worry about that full DevOps cycle. So Docker and Kubernetes could be very daunting, but as a developer, all you say is, hey, I'm going to deploy my application on Kubernetes or on OpenShift. So when I do a git push, OpenShift will build that entire CI/CD pipeline for you, and it will take care of running a private registry. It will host all of that. It will do that pipeline, Jenkins, all of that orchestration, and then take you from there. Another tool that you want to look for when you're looking at CI/CD pipeline, particularly with Kubernetes and Docker, is Shippable. Shippable is a small company based out of Seattle, and they are actually used as a CI tool for Kubernetes itself, for the Kubernetes team. So that's something you want to look at. Shippable is a good example to look at. Docker tooling. Yeah, Xavier is pitching his talk. Full demo today at 6:05 p.m. in room 5. Can Docker be used to boost developer productivity? Now remember, Docker can be used to solve world hunger, hopefully. Now, Docker to me, when I look at Docker, it really allows me to reduce the impedance mismatch. That's the biggest thing I see, that, the fact that you can say, hey, it works on my machine, it doesn't work on yours is not a bug. So that is the biggest thing it brings out. So it depends how you define developer productivity. To me, that's a huge developer productivity. As a matter of fact, on GitHub, I want a standard field. You file a bug, you put a Docker image right there. It's reproducible. Then you say Docker run, and then it should just reproduce the bug for me. So to me, that's a big boost in the developer productivity itself. Microservices design patterns, I'm going to be, that is my university for tomorrow, and I don't want to leak my presentation, so I will show the result tomorrow. Okay, any questions in the room?
Yeah, I have a question regarding the scaling up and down. So we are scaling containers, but is it possible also to swipe nodes, for example, like Amazon nodes?
Yeah, so both Kubernetes, the question is, can I scale only containers, or can I add nodes as well? And that is multi-cloud. So both Docker Swarm and Kubernetes, in that sense, allow nodes to be dynamically added and removed. The example that I showed in terms of Kubernetes, the node can go down, and that's okay. The Kubernetes will automatically reschedule the container, the pod, and it does that by using kubelet, because kubelet is responsible for the health check, and it talks to the master and then figures it out. Same thing with Docker Swarm as well. All right, you can always send me a mail, Arun at couchbase.com, or send me a Twitter message. Thank you so much.